right. Hi, everyone. I'm Stefano Stabellini. I'm a fellow at AMD and one of the Xen maintainers and Linux kernel maintainers. Last year at this conference in 2023, I gave a presentation together with Senthil, who is the safety manager at AMD, about a project to make Xen, the open source hypervisor, safety certifiable. So today I'm going to give you an update on what happened since last year on a bunch of areas, including Misra C, requirement, traceability, and more. But before I do that, so there is a link in the slide, by the way, to that talk. But before I do that, I'll give you a brief summary of what I said last year, just to give you enough context to understand the update. So embedded hypervisors are, in a way, they have some similarity with the hypervisor you might be used to in data center and cloud, but their purpose is a bit different. The goal is isolation and freedom from interference between multiple domains. So the hypervisor is used to run a critical workload like Zephyr or another RTOS, and in full isolation from something else, which could be Linux or Android. So mixed criticality, fault tolerance, real time, and strong isolation are all key properties. So Xen is an embedded open source hypervisor. It's an open source project under Linux Foundation, very well known, and has a very strong review and security process. It's a reference open source hypervisor for embedded and automotive in a number of open source forums and industry forums. ARM and x86 has fully supported architectures. RISC-V and PowerPC ports are in progress. The Xen open source community is a diverse multi-vendor community. As you can see on the right, there are a bunch of companies contributing to it. I'm proud to say that AMD grew to be the third, almost the second, by just less than 10 commits to Xen based on the number of commits for the 4.18 release. Right, I'll give you a brief overview of why Xen is great for embedded, at least in my opinion. So especially for the one of you that have heard about Xen many years ago, maybe early 2000s, when we were doing mostly servers and desktops. Since then, a lot of time has passed. A lot of energy has gone into making Xen a great fit for embedded, and I'm only going to mention a few of these features. Some of them are new. Some of them are always been there, but they were maybe not exploited to the fullest. Let me start from saying what's really making everything possible is the fact that Xen has always been a microkernel, as a microkernel architecture, and what that means is only the hypervisor core need full privileges, and that's quite small. It's less than 50,000 lines of code on ARM, and that's with a configuration you can get today without really chopping off big part of the code, which you could do if you have a specialized setup. So large part of the code can run without privileges, without any privilege, or just a limited amount of privilege over the system, which makes it, safety a lot easier to achieve. These are a few features that we have introduced in the last 10, 15 years now, specifically for embedded. One of them is DOM zeroless. Typically Xen always relied on a big Linux VM to start first and then start and manage other VMs. Now that's gone away. Not completely. You can have it if you want to. It's optional. But Xen is capable of booting multiple VMs based on initial configuration, multiple VM in parallel, just at boot time. Because the domain creation now is taken care of directly by Xen itself, DOM zero is not necessary. You can have it if you want to, but you can have fully functional system without a DOM zero. Which means, you can have static partitioning systems where Xen, once the system is booted, is basically invisible in the sense that it's set up, the domains, device assignment, you don't really see it any longer unless you want to. Other features are real-time support with the null scheduler that does static allocation of virtual CPU to physical CPU without any scheduling for best latency. Cache isolation in software thanks to cache coloring, so we can detect the relationship between memory addresses, cache lines, and make sure that each VM has always separate cache lines, so that cache interference has been reduced to 0. We support both XenPV drivers and Vert.io for device sharing, and especially Vert.io, we support Vert.io with a memory-safe way of exchanging memory between VMs. And finally, if all of the above did not convince you that Xen is embedded, this last point definitely should, because Xen is now running on MMU-less systems. These are microcontrollers that are so small they don't even have an MMU, like Cortex R52 and Cortex R82. And Xen is capable of running there. OK, so Xen at AMD is the open source reference hypervisor for embedded and automotive for both ARM and AMD x86 platforms. And we have a team to develop, enhance, and support Xen for embedded and automotive. And we have a number of customers across verticals, from industrial, medicals, automotive, and more. And many of them require real-time isolation between VMs. OK, so this is the last slide, I believe. Yes, it is, on the summary. So that's the, this is the scope and more information about the project that it was initially discussed last year. So we are working on making Xen safety certifiable for AMD platforms, both ARM and AMD x86. We are targeting I66158 SIL 3, which is the industrial safety standard, as well as ISO 26262 ASIL D, which is the automotive safety standard. ASIL D is the strictest level for automotive. The certification is based on Xen upstream community processes. Now, I cannot stress this enough. Now, it happened in the past that people take an open source project and then import it within the company, close the doors, and then do everything in private, including major code changes, review process changes, everything changes, and then they safety certify that. Now, this is not what's going on here. So all the safety certifiability artifacts are all based on upstream activity, upstream review, upstream code bases, upstream everything. A lot of the thing, actually everything I'm going to talk about in this talk in the sense of Misra C updates, requirement is all either already public and upstream or going upstream. However, some of the safety artifacts and documentation might be available for AMD customers. All right, so what's the scope? So we are targeting Xen AMD x86 with the newest set of drivers for hypervisor extension, IOMMU, HPET, and PCI, similar for ARM, SMMU v3, Geek v3, the Arch Timer, hypervisor extension, PCI. Because Xen has so few drivers only for the core components, we expect it to be easy to port it to future generations. We also have the enabling component for PV drivers and Vert.io for memory sharing and device virtualization between VMs. We have no OS hypervisor dependency. Now, this is very important. You can run as many safe OSs as you like. You can have one Zephyr safe, two Zephyr safe, all the combinations that you can imagine. There is no ties between the VMs and the hypervisor, whether the VMs are safe or non-safe. You can come up with the best combination to fit your use case. We are using DOM zeroless for domain creation, so you don't need to have a DOM zero. You can if you want to, and we'll support real time. OK, now, this is the intro. Now, I'll tell you a bit about the updates and what happened in the last year. And I'll give you updates in three major areas, which are Misra C compliance, requirement, and traceability. Let me start from the first one. So Misra C is a set of coding guidelines to write safe C code. And the goal is to improve the safety and the quality of the Xen code base. The activity is to look at the Xen guidelines, evaluate them, discuss them with the maintainers, accept them into the Xen coding guidelines, and fixing violations or deviating violation. Deviating means we are saying this is safe even if it doesn't meet Misra criteria, but we are explaining why it is safe. Another important point here is Misra needs a checker, an automatic way to spot and detect violations. And we are using Baksang Eclair Misra C checker. What about software safety requirements? So these are detailed documentation of the behavior of Zen. And we have worked on defining how to structure the requirements that are hierarchical, and how to trace the requirement. That's the traceability point there, the last update. Okay, I'll start with Misra. So initially, together with Baksang, we selected 133 Misra C rule candidates. We have already discussed 118 of these rules. 96 have already been adopted into the Xen guidelines. As you can check out docs Misra C rules.rsc, that's the document that keeps all the guidelines that we have adopted. There might be a couple missing because they are on the mailing list waiting for the last ACK. 17 of the remaining ones are candidates for mass adoption in the sense that are already clean. We have no violations, but we still need to discuss them to make sure before checking them in. There are really only 8 rules that are left to be discussed. And so we are really close to the end of that part of the process. In the Xen 4.18 release, we have 148 commits to fix Misra C violations by Baksang. And we went down from the initial count of 2 million violations to 100,000. So 20x improvement from the beginning of the project to now in 1 year. So some other numbers. So now we have the Eclair Misra C scanner integrated in the GitLab CI loop for upstream Zen to detect regression and violations. We have 69 rules that are checked and we have 0 violations. So they're clean, with 7 additional that are clean only on ARM and 4 that are clean only on x86, still work in progress. 35 rules are checked against regression, meaning they're not clean. We have violations, but at least we are spotting if they're getting worse as part of the CI loop. Another thing that we have upstreaming Zen, and especially this is useful for other open source projects, they might want to take inspiration from this. We have a pretty sophisticated system to handle deviations. We handle both project-wide deviations. These are documented in deviation.rst. And we are also, and we have the Eclair configuration to match also in Zen.git. And for individual specific violations, we use the SAF tag as an in-code comment. So basically, we add an in-code comment, as you see in the picture here, with SAF and a number that then corresponds to an explanation. And also, we can convert that tag into tool-specific tag, like Eclair tag, Coverity tag, CPP check tag, to make sure that the Misra C scanner does not flag that as a violation any longer. You need clean scanner results for the results to be useful. So when you deviate something, it needs to disappear from the list of the violations. Okay, so this is really what I wanted to focus today, not the numbers, but the lesson learned. And after 1 year and many, many violations fixed, I think we have a couple of lesson learned to share, and one of them is very, very important to be flexible on and being able to adapt the Misra C rules to the project, especially when you start with a mature project with already a rich history and also high quality of the code base like Zen. And the reason is many of these rules, as you'll see, they are, everyone will agree to the spirit of the rule, and they really highlight a real problem, but often taken as is, they trigger way too many violations for a project to be able to handle them, but also they go against some of the culture of the project in terms of developer confusion. So one of the important things about Misra is to address developer confusion in the sense of writing code that is clear. However, what is clear from someone that has experience with Misra and a lot of years working on Misra C project might be not as clear as to someone that has 10 years instead working on Zen. So the developer confusion is a bit dependent on the culture of the project, and I'm going to highlight some of the examples. There are also a couple of additional things that I want to tell you about encapsulating tricks and Kconfig and Misra, which are interesting. So this is an example of a rule that is a bit too restrictive, and that is rule 16.3. That says an unconditional break statement shall terminate every switch clause. What does it mean? Every case statement in a switch should have a break. So taken as is, it's hard to disagree with it. In fact, it's really highlighting severe potential bugs, right? So probably all of you have seen bugs where a break was forgot and then you fall through by mistake. That causes like all sorts, aside from malfunctioning, even security issues. It's definitely severe. So you want to be able to take advantage of Misra. You want to take advantage of Misra scanners like Eclair to detect this problem, fix them for you, right? At the same time, taken as is, it has a couple of issues. But first of all, obviously, there are cases that explicitly you want to fall through. So you need to deviate those, but those, it's done on purpose that you deviate them, meaning that it's done on purpose that you need to explain, okay, here I want to deviate, I want to fall through on purpose. For that, we add the fall through keyword that we can add in between, so to clarify the fall through is intentional. So that's not an issue. The real issue is, you get to this point, you talk to the maintainer, everyone agrees. But then you look at the implementation, and turns out that when they say break in every case, they mean every case. So what if a case finishes with a return? What if the case finishes with a continue or a goto? You still need a break after it. Now, I can see that if you work with this kind of code style all your life, you see return break come natural to you. Me, that I work almost 20 years in Xen, I see a return and a break, and I think, wait a second, was there a Nash define taking the return away? Is there some self-modifying code that is kind of editing the return like assembly somewhere else, changing it into? I start having conspiracy theories in my head when I see something like this. So what we did is we deviated continue, goto, and return because they are intentional, but still accepted the rule so that we can still use Eclair to scan for these bugs. And this is where one of the key, maybe the most important takeaway from this talk is you need a Misra C scanner that is flexible. You need to be able to do something like this, and the Misra C scanner to follow you. So you need the Misra C scanner able to deviate, as an example, continue, goto, and return. I have another point is about clever tricks. Like we all have clever tricks in the code. You see an example here on the top where you have that trick extract the least significant non-zero bit. Okay, it works. Trust me. So the point is, you have it in the code. What do we do? Just move it in a macro, move it in a static inline, then you deviate the macro static inline. That alone is explaining that what the macro or static inline does is valuable. And then in time, if you want to, you can change the implementation to something that is more Misra C compliant. I have another very interesting example, and I think this is one to kind of follow through our mental process that I think will help you if you have your own project and you want to do Misra C. So rule 10.1 says, operands shall not be of an inappropriate essential type. Now, I understand you don't understand if you don't know Misra, but I'll give you, it's too long to explain, but basically Misra prohibits certain operands and operations combinations. As an example, it prohibits arithmetic operation of integer and float, or integer and Boolean, or enum and characters, for good reason, right? So 10.1 is an important rule, cannot really be easily be dismissed like overly complicated. It is real. It highlights undefined behavior in C, unspecified behavior, implementation-specific behavior. There are real problems here. Again, you want the Misra C scanner to tell you this is a problem. However, you enable 10.1 on Xen, and there are 269,393 violations on x86 and 65,731 on ARM. How do you go about it? So first, you look at the details, and there are certain operands and operation combinations that are guaranteed to be safe by modern version of the C standard. Then, given the assumption that Xen makes about ARM and x86 architecture supported or C compiler supported, there is a bunch of other operands and operation combinations that are also guaranteed to be safe. Finally, certain combinations are marked, I mean, they're prohibited by this rule because of developer confusion. But like we said, some of them, they don't confuse Xen developers, such as implicit Boolean conversion. This is when you do if with a pointer to check that the pointer is not null. Right? Everyone, I've done it for many years, doesn't confuse me, but Misra does prohibit this kind of behavior. So bottom line, after we deviated all of the above, we went down from 335,000 approximate to only 95. And these 95 remaining are probably genuine issues that need to be addressed, and we'll work through them to get full compliance. So, and you still get the benefit of using the scanners to check for the real issues that, those are still, checked and not deviated, right? So that's an example of how to deal with a particularly difficult rule, but important. All right, one more thing I want to tell you about is Kconfig. So in modern open source project, we all use Kconfig a lot, in Xen, in Zephyr, in Linux. Why? Because we target very many different configuration, use cases, and it's natural to use Kconfig for that. Now, when you come to Misra, as we are adopting Misra, I mean, this is a process, right? We are not going to go from 0 to Misra for everything, and certain options don't make sense for safety or don't make sense for embedded. So you want at the beginning to take them out. You want to reduce the scope to do Misra done well for the subset that is relevant for safety. And then one day, maybe you do it for everything, but you need to start from somewhere. So how do you take this out? You use Kconfig, and you disable the option, right? And that's where the problem lies. So traditionally, we have used all preprocessors, like in the left, to take something out, like config foo. You take it out, and then you disable the code. However, exactly for example, like the one in the picture, it's always been a bit confusing. Preprocessor doesn't mix too well with C code. So many projects, including Xen, Linux, and others, are moving toward the right. Right? Is-enable is a little trick. What it does, it becomes if 0 if the Kconfig option is disabled. So from Xen point of view, left and right are the same, and right is preferred because it's easier to read, it flows better in C code, it's easier to review, and so on. So why? Because if 0 is automatically disabled and removed from the compilation by the compiler. That is not what Misra thinks. So from Misra point of view, only things that are removed from the preprocessor are actually removed. Now, this is another opportunity for deviation. So if you check that with the compiler that you allow, actually the code is indeed removed, if not by the preprocessor, by later stages of the compilation pipeline, then you can deviate this and claim equivalence. And that is what we've done in Xen project. Okay, for the people that were not interested in Misra but interested in other things, this is the time to pay attention. So I'm gonna talk about requirement for a bit now. We have not upstreamed any requirement yet, but we have written about 300, and we are about to start upstreaming them. And I'm going to talk to you about what we have done, what we intend to, how we intend to upstream it, and some of the key information about requirement for safety and open source projects. So first of all, what are the requirements? Requirements are a detailed description of all the software behavior. So you need to describe everything that the software is supposed to do if you then need to test it, right? I mean, if you don't know what the software is supposed to do, how can you test it? I mean, you can test it, but then you don't know what the outcome, if it's supposed to be a success or a failure, right? So you need to describe everything so that everything then can be tested, right? So the requirements are this description of everything. When I mean everything, I literally mean everything, like all the features, but also all the behavior in terms of error handling, faults, really anything. So what we did is we split the requirement on 3 levels. The requirements are typically hierarchical and are the same. So we divided them up in 3 levels: market requirements, product requirements, and software safety requirements. Market requirements are the highest level. For each market requirement, there are multiple product requirements that go more into details. They start to be Xen specific, but they're still high level. And for each product requirement, there are many software safety requirements that go even more into details. That's the most fine granular level, and this goes into really all the nitty-gritty details about how a driver is written. Here in the slide, you see M to N instead of 1 to N, because sometimes one product requirement can link to more than one market requirement. So to be precise, I wrote M to N. But conceptually, you can think of this to 1 to N, and from product requirement to software safety requirement, again, 1 to N, although it's not exactly always the case. So this is an example of a market requirement. So I'll let you read it on the slide. These are 3 real, in fact, market requirements that we wrote. So some key points here. So the main goal of the market requirement is to identify the scope of the safety certification project. What is in the scope, what is out of the scope, and the expectation from the point of view of the customer in terms of features that they need or use case. So it's written with a very high-level view of the system. So in this case, there is a requirement to statically create VMs or being able to assign devices to VMs. This is the very high-level way the market requirements are written. Like I said, from each market requirement, there are multiple product requirements. So product requirements, like they start to be Xen specific. And as you can see on the right, they start to be a bit more finer granular. So it's not just you need to start VMs. You need to start VMs that have an emulated UART. They have a way to do I/O, internal console I/O. They need to have an emulated timer or a sort of a timer. You go more into details about what the environment is actually supposed to look like, and they also start to make Xen-specific assumptions, such as Xen shell provides this, Xen shell provides that. They're still written with a high-level view, so you wouldn't be able to test one of these product requirements directly. There are very many ways in which you can provide an emulated timer, as an example. Very many details that could change. That is, the most interesting one, to be honest, as an engineer at least, they are the software safety requirements. Because those are the ones that really describe the whole lot. They need to be individually testable. So they need to be clear and unambiguous so that an engineer, just looking at the software safety requirement, together with the help maybe of the architecture document that describes the whole architecture and give you a bit more of an overview, an engineer needs to be able to write a test. A test without looking at the implementation in Xen at all, right? Just looking at the software safety requirement and maybe a couple of additional docs. So they need to be super fine granular. And here there are some examples, right? They talk about how the timer can be probed in device tree, how the probing looks like. They talk about the clock the counter frequency, how it can be detected. They talk about how you can access the register of the timer, which register are available, what is the MMIO space of the device, how to trigger interrupt, both physical and virtual interrupt, basically all the details of the feature. So yeah, so here are all the key features of software safety requirements, so written in English, from the perspective of what Xen is supposed to provide. So they need to be independently testable. They're in the most granular form. You should be able to write a test just looking at them, and unambiguous and traceable, which is the next topic I have for you. So now the market requirement needs to link to product requirement, which needs to link to the software safety requirements, which needs to link to the test all the way to the result. all this graphful linking needs to be done somehow. So as we are about to upstream the requirement to Xen, how do we go about it? So traditionally, requirements were stored, handled, reviewed, and versioned in complex proprietary solutions such as JAMA. And this tool will give account permissions, version on the document, right or lack of rights to change the documents and do review comments, all of that within this tool. Now, as you can imagine, this does not go very well with an open source community. Why? First of all, you need a way to give everyone accounts. Second of all, these documents were meant to be written in Microsoft Word or PDF format, which the community has not been traditionally very good with. So instead, what we are doing, we are writing requirement as RST and Markdown docs. So there are already a trend in open source projects to write documentation as Markdown or RST. Now, as you can see, like everyone on GitHub is writing, a README that gets automatically rendered by the GitHub UI, right? So everyone is familiar with this process. Sphinx is used very commonly to generate PDFs from RST files. The device tree spec itself, I think, is written in RST, if I remember right. The point is widespread in open source. Why do we like it? We like it because you can write this documentation exactly with the same tool you write code, like Vim. You can review this document using the same review tools, like either email, GitHub, whatever you use, and you use the same versioning system that you use for the code for these documents. So it fits extremely well into the community processes. Everyone is already familiar with them. They can be productive immediately, right? So this is why we adopted writing requirement as RST files. Or it could easily have been Markdown, but we picked RST. They're very similar anyway. So if you write requirement as RST, what is the gap? The review, you can do it on mailing list or GitHub as a code. You have a versioning system with Git. What's missing? The missing piece is traceability. How do you do all the linking and how do you prove to the assessor that the links are all complete all the way to the test? The linking part is a missing feature. Because if it wasn't for the linking, you wouldn't need anything except for your Vim and RST to HTML or RST to PDF, right? You will be sorted. So thankfully, there are a number of open source projects that stepped up to solve that problem. And one of them, the one we picked, is OpenFastTrace, but there are many others, including StrictDoc and Basil, and there is a Basil talk today, which I encourage you to go and attend. My point is, all of these projects will solve the issue for you. And I'm going to talk to you about OpenFastTrace specifically, but any of these are great solution for your project. So OpenFastTrace is a project that handles traceability in Markdown file. RST support is actually in progress. It handles this linking between requirement and also all the way to the code. It detects missing link or obsolete links. And it generates the report in HTML. So how does it work? So one interesting feature of OpenFastTrace is that it basically supports requirement written, yes, Markdown on RST, but basically in free form. It doesn't mandate a specific format for your requirement. So you can write whatever, in whatever format that you like. You just need to embed a tag. So the tag over here at the top is the tags that identify that requirement and its version. And needs is the dependency toward the more finer granular requirement. Going in here, this is the more finer granular requirement that satisfies the dependency, and as you can see, has its own tag, and special keyword covers to link back to the previous higher level requirements. With this tagging system, that's all OpenFastTrace needs to detect the linking and solve the traceability issue, all the way to the code. So you can embed these tags also in code itself as in-code comments. And the top one you can see is the tag to say this is an implementation of a test for a requirement, right? It says that stands for the implementation. On the way to the right, it says test. This is implemented the test for the requirement. And the one at the bottom is the script that runs the test. So that is the actual test running. You are expected to get the result out of that. That's it. So it's extremely simple. And at the end, it generates something like this for you. So this is a web page with a bunch of links. They are hierarchical, and you can see when the links are met, all the dependencies are satisfied. There is a green check. And when there is something missing, there is a X, red cross to say you know. So if you update one requirement, you are expected to update the version on the tag that you see. Like, for instance, here, that's the version of the tag. And if you change the version of the tag, then OpenFast Trace can detect if you haven't changed previous versions. So if there is some obsolete links in the pipeline. So this is an example when you click on expand and you see more details about the linking and whether any of them is missing. That's it. Conclusion, Xen is an open source project under Linux Foundation. We have a healthy and diverse community. AMD is one of the top contributors. Xen is a great embedded hypervisor, and we have a project to make Xen safety certifiable for AMD platforms. We are doing a couple of things that are interesting that we're doing right now are Misra C and requirements. For Misra C, one of the key conclusions is the configurability of the Misra C scanner, Eclair in our case, is absolutely essential. You need to be able to adapt the Misra C rule to your project in the best way to take the most advantage of Misra, and for that, you need a very adaptable and configurable and flexible Misra C scanner. Second key conclusion for you is you definitely need the Misra C scanner integrated in the GitLab CI or CI loop that you have as soon as possible to help ease the burden on the maintainers and also reap the benefit of Misra. The higher quality the code, the more deviation are expected, but still Misra offer potential for suggestion and help in spotting and spotting potentially severe problems. For requirements, instead, my conclusion is use requirement as code. Use Markdown, use RST, write plain text documents, and use one of the fantastic open source tools out there to handle traceability for you, such as TrickDoc, Basil, or OpenFast Trace, as we did. And the upstreaming of the requirement will be coming soon. That is the end of my talk, so I'll take questions now. Yes, sir.
Thank you, Stefano. It was really great presentation and interesting. I have a couple of questions. So the first one is about Misra. Now, if I remember correctly, you said at the beginning that Xen is as a microkernel architecture, and it is relatively small, like 50,000 line of code. And now I see that, I fully agree about, like it is impossible to have full Misra compliance. You need to assess the different rules and pick up those that, would apply and maybe, justify why those that do not apply actually are okay to be waived. However, if I remember your presentation, you say that you still have 65,000 outstanding violation.
Yeah, something
so
like that. Yeah.
It sounds more, that you have like more violation than line of code.
This is because, so first of all, the 50,000 line count is for ARM. There is also x86, which is bigger. But also keep in mind that when the violation counts, and this is how, then you could ask the same question for the initial number, there was 2 million. How do you get 2 million? That is because, first of all, you can have multiple violations on the same line. But more than that, if you have a violation on a macro, like test bit, test and set, the violations are reported not as the macro definition, but as the macro invocation. So every time you call, set bit, test bit, they trigger a violation. So instead of having 1 for test bit, you have 1 million,
Okay.
right? I think it's more, this is why the absolute number doesn't tell you that much. So in my original version of the slide, and maybe that's the one is online, I made a change just this morning to give you both the before and after number, because it's the relative number that is more interesting. What's interesting went from 2 million to 100,000, right? What is exactly 2 million or what is exactly 100,000, you need to really look into the details to understand, right? Because if you have, out of the 100,000, you have 90,000 test bits, which we do, by the way. Test bit is one of the outstanding ones. You see what I mean? This is why we are close to completion, even so we are 100,000.
Okay, so yeah, my question was more like, I was wondering basically if, rather than looking at, each Misra C rule, one by one, maybe if, maybe you already tried, I don't know, but if you look at table 6 of ISO 26262 that, specify the, the coding and design principles, right? And maybe starting from there, you could, find a subset that is more also that fit better also with the open source development process that is already in place. Because I mean, I don't know, but I'm wondering if, like, even if we were able to fix all this violation today, would all the rule that we impose be compatible with the current development process of Zen? I don't know.
So first of all, yeah, you raised a good point, and we did that analysis, and we came to the conclusion that the Misra C was the best. But let me explain why. So first of all, one disambiguation. ISO 26262 does not require Misra C. So it only requires good coding guidelines. So you could pick any set, including your own, and demonstrate this is a good coding guideline. But if you look at all the possible safe coding guidelines for C that there are out there, not only Misra C is the most detailed, also most flexible, but it's the one also with more mature tooling. So good luck getting something like Bugs and Eclair on your own set of guidelines, or Cert C even, right? So the point is, Misra C had the most mature ecosystem, the most well thought through rules, and also one of the things that we liked about Misra C is it never compromised the quality of the code for compliance of the rule. So now to answer your second part about is it compatible? So this is why it's very important to add the Misra C scanner as part of the CI loop. So if you add more violations, they immediately get detected and so then the contributor or the maintainer can address the violation and fix them. The process of going rule by one is extremely important, because you cannot really take them wholesale, because nobody will really learn. Looking at the rule one by one is also so that people learn them, get the buy-in from the people, and make sure that everyone is aligned behind supporting a rule and why, right? And time will tell. So we are still just at the end of the project now. So we'll see. Let's have a conversation in 1 year, and I'll tell you.
Yeah. and I also had another question that was about. You mentioned traceability from requirement to code to testing. You didn't mention about any software architectural design that for ASIL-D, for example, has a very strict, rules. You need to apply semi-formal methods, and also the verification of the design, is quite strict. So, but do you have any activity in place?
We are
in that
working
regard?
on we are definitely working on an architecture document, and indeed it's not easy. So, but we made progress. We wrote a few chapters, but I didn't have enough information really to share in a talk.
Okay.
But yeah, that activity has started.
Thanks.
What does it take for a new customer to take upstream Zen into production?
Well, So into production, you could take it straight away. I guess you're asking into production with safety certification.
Yeah.
So for safety, there is quite still a bit. Like even if you include all of the things that were not made public yet, we're still kind of maybe halfway through the process, right? So, but the current status of upstream Zen is Misra is almost there, and the requirements are about to start. So, to give you, we do have some testing infrastructure in place already. Like we have the GitLab CI testing infrastructure to trigger a variety of tests from Linux to unit. I mean, more smaller tests. So that is in place, but we don't have enough, for sure, tests to cover what safety requires. So there is still some gap, but yeah.
Okay, thank you.
So I'm not familiar with ISO 26262, but do you guys have any needs for test grading, or that's what they call it in AEH land, but maybe like MCDC coverage?
So MDC, yeah, that's the 017NC.
Yeah, that's where I'm from.
Yeah. Okay, no, so we had people asking for the 017NC, and we can have a conversation after the presentation. MDs, that's not one of the things that we're planning to do. So ISO 26262 maybe recommends it, that does not, well, I should say.
Well, do you even do statements?
I66158 at least
Yeah.
recommends it, does not requires it, so we're not planning to do it.
Okay.
We plan to do coverage. Like
Just statement coverage or decision coverage? Okay.
Yes. Yeah.
So the safety certification has to be happened only for like DOM 0, or if you are running a DOM U, how do you?
That's a good question. So the reason why we really did DOM 0 less is so that you don't have to have a safety certified DOM 0. But you can if you want to. So if you have your safety certified RTOS, you want to do some monitoring over the other VMs, for instance, good idea. You can do a DOM 0 privilege monitoring anything safe VM. Like, that is okay. But thanks to the DOM 0-less architecture, the idea is you don't have to have one. So if a customer wants, for instance, to have only like non-safe VM and maybe an ASOL B lower level of safety RTOS, we would allow that. And we would enforce isolation and freedom from interference for all VMs. Yeah. So the DOM-Us don't have to be safety certified, but one that is safe, you could make it DOM 0 if you want to, optionally, or even a partial DOM 0. Like you could give some of the privilege rather than all. Yeah.
So does that apply to all the like cache coloring features, all the stuff?
Yeah.
Okay.
So if you had a DOM 0 and you wanted to restrict it, doesn't that mean you need the security module in Zen? Is that part of what you're going to certify?
So there are two things that we're looking at. So one is there is already a Zen security module, short for XSM, which allows you to specify extremely fine-grained permissions. So that's one option. What we're also looking into is whether we can have a very simple check, like a trivial check to say, well, this, let's call it DOM 0, it's not really DOM 0 anymore. You can have some special operations, but only towards non-safe VMs.
Oh, okay.
Right? You could specify that in XSM, but XSM is like SC Linux.
Right, but
For
is
better or for worse.
XSM going to be part of the code base that gets audited for safety?
So we still have to make the decision whether to do XSM or the simpler version, let one VM to do things to non-safe VMs or not to safe VMs, but one of the two will be in, yeah.
So my real question was about ASIL D. So you talked about it, targeting ASIL D. Is that on lockstep processors, or you think you could do it without
So the
lockstep?
safety certifiability for Xen is as a safety element out of context,
Okay.
which means we don't really say what the hardware is going to look like except for basic assumptions. But yeah, typically the hardware is in lockstep, right?
Okay.
But yeah,
Okay.
we will not say one way or the other. Yeah.
Is that time? All right.
Okay. Thank you much for all the questions, and I'll be available after the talk if you have more, and thanks for attending.
Yeah, I want to mention. Do you have the clip-on mic?
Yes.
Yeah. Just here because I saw it laying around there.
That was his preference. Was to
I'm Nelson.
Nelson.
Just thought I would say hi.
Okay.
One little sound check. Yes, I hear myself from the speakers. Perfect.
For Elisa, which Philip is going to present about.
Oh, maybe you can answer my question.
Okay.
I was about to look it up, but what is Elisa?
So, yes, Elisa means enabling Linux in safety applications.
Okay, okay.
So it's I think what we're trying to do is trying to get, people from different industries, mainly automotive and aerospace, and also, Linux leaders, to come together, agree on, best practices. We're not trying to engineer Linux as safe Linux, but trying to, push some of those requirements up, hopefully, a lot of it is really sharing knowledge and
Is part of it exploring ways to use Linux and safety applications without changing Linux? That's what you're saying. Or does it involve also changing
trying to get
Linux?
these two communities to talk together, I guess. Linux open source and people in the safety community, probably before the project, they weren't really talking to each other, but now we're trying to get them to talk to each other.
Okay, got it.
So that, we can come to some consensus. And I know, for Elisa, we have some tools where we could do requirements, traceabilities, and code coverage, and things like that. So Philip will tell you more.
Okay, okay.
Yeah. So,
And those tools are open source tools?
yeah. One of the tools was donated by Red Hat. So, actually, there's a session about it this afternoon for Basil.
Okay, yeah. Stefano mentioned Basil.
Yes,
Yeah.
yes.
And he said he's using open source Trace. And the other one he mentioned, Zephyr is using for their safety effort.
Yeah,
The strict
Zephyr,
doc.
yeah, right. Yes, Kate mentioned that in her keynote. Yeah. information there, and I think it's a very challenging problem. Right?
It is,
In this
yeah.
case. So I think, yeah, there's ways to go.
My focus is mostly on the Zephyr side, and
Okay.
kind of looking at what Linux is doing
Yeah.
as an example of what Zephyr can do.
Okay.
So I'm familiar with Kate's work.
Yes. And Nicole. And
Nicole's here?
she's not here.
Okay, yeah.
Yes, I guess I'm online. We're 9:55 exactly, almost 7 in my home.
Thank you.
Yeah, I talk about the Elisa project, and I changed a little bit from the naming. Normally it says enabling Linux in safety application, and I understrike this with open source this time, because I want to include also the other projects, like we just had Stefano in for the Xen part, and we have the Fire project. And as I have a tendency to forget it to say it at the end, I start with saying we also have Swag around, so if you want to get some Elisa things later on or so, should be something in the back. Other than this, I gave an overview about the Elisa project several times during the last years, and this time it's just a very short one to just get people on board on some topics, to see what challenges are, and I really hope for interaction, that we get into discussion and talk, which should also mean that it's not you only asking questions and letting me answer, but also that you can give a statement or you give a question, and someone else who has the view can give the answer. And we have Min in the back, and she's very helpful with sharing then the microphone so that we can move things on. It's very important that everybody speaks in the microphone, because we have the virtual audience. Unfortunately, we cannot take the questions from the virtual audience. Maybe there's a technical solution. I didn't look at it before. But now let's look into the actual session. So what we talk about here is open source projects, working with our functional safety, and there's Deathfire. They have their own summit here, so we don't have too much from them today in here. But then we had the Xen part, so Stefan was giving good overview, so I've just a single slide on this basically. And what you may have seen on the Embedded Open Source Summit opening keynote from Kate, she said that there's Yocto involvement in, because you can build basically all the 3 projects also in Yocto, and we need a lot of other tooling as well. So Yocto specifically is not touching the safety element as a project, but it's a nice way to integrate, creating ASBOMs, getting support, and so on. Yeah, so maybe first thing about the Zephyr project. What's very nice is that it's kind of a designed RTOS, and it brings a certification part from the beginning. They are creating safety manuals and so on over time. What's important to see, it's for premium members. So it's because, as you may know, safety certification is typically very expensive, and you need to find a way to finance it. And here it's done by the premium members, which get full availability to see all the documentation. Still, the source code, which is generated, and the material, the testing, and so on in the Xen project is available to everybody. It's basically, you get the things, you get your tools, but you just don't get all the full details, what you need to know how to safely operate them to get the manual around. This is for the premium members. And this was a little bit closed over some time, and now they open much more. So every Tuesday afternoon European time, morning time, West Coast, there is a work group meeting where they discuss about like safety requirements tooling. They use strict docs for creating their requirements, parts, traceability. And yeah, this was basically on the processes. Recently, they also came up to discuss about the actual requirements which they put to the system or to the Zephyr. This is another workgroup meeting. If you're on the mailing list, if you go to the Tuesday meeting, you will get forward to the other meeting as well. I guess it's on Thursdays or Fridays, but that's going on. What makes Zephyr sometimes a bit hard to get forward with safety is that there's a lot of sensor people in there, or some chip producers, or SoC vendors, and so on. And a lot of focus is on small devices, on IoT. And even if it's on real time, it's not necessarily on functional safety for the loss of human life or risk of human life loss. So therefore, to encourage the community to follow all these processes, write down the requirements properly, so that's not easy. That's why you need additional resources, engineers, and yeah. you have all these non-heavy, non-safety use cases. What's really cool about it is you have a smaller footprint, of course, from the size of system compared to a Linux system, and you still get a strong ecosystem with a lot of contributors. I mean, you see it, they have their own track, and it's full, and there are many people in there. So they're stealing also here and there other audience because it's such a fancy thing. Many contributors are in, so that's quite cool. And the POSIX compatibility is may or may not be important for one or the other. Yeah, for Xen, a bunch of you have been in the last one. I see a few new people coming around. So Xen and security is well established. They had the security working group already since 2010. There's like isolation as top priority, and you can see already from the whole environment of Xen, they are much more focused on security, industrial grade, critical operations, and that's what they have. So they have the really rigorous quality process with strong traceability, commit traceability, synth the first commit, double stage pipelines, and it's really in use also in critical infrastructures, data centers, and so it's real something there. And compared to the Sapphire project, whereas with the premium member AMD with their hardware is on the safety certification path. So in case you want to make use, still you have the open source version of it, the software stack. This is all there, but the manuals, the testing part, the results which you may need to get a safety certified product are under commercial conditions with AMD. Timeline to be seen. I think that's more hidden behind the scenes. And also here, there's, I think I'm not completely right with the phase 1, phase 2, but they keep some part open. They show that the concept is there because it's very important also to get customers to show, does it really work? So is by principle feasible, and that's also what we saw in the previous presentation. What are elements? Is there a proper way of convincing people to say, yes, I believe in the topic, and then do the final assessment afterwards to really come to the safety certification, right? The Elisa project is actually a little bit different in the way of approaching the things. We get often addressed by people asking, when will you deliver a safe Linux? And we're not delivering a safe Linux. We let this do other people. We help these integrators, system creators, integrate whoever's in there, major people, and we have these as members. So we have our Red Hat in SUSE, Canonical, Wind River, Electrobit, who also provide automotive parts. I'm coming from Bosch, so we're also in. So there's a lot of people who build actual Linux systems, know how to create safe system Linux parts, and need just to support and bring in work packages and artifacts here. What's very nice is the reproducible system which we are targeting, because what we learned is when many people come in and out of the community, they bring different background. So we are working on a step-by-step guide. It's continuously maturing, and this is where you really have a CI pipeline which starts from documentation up to testing, and you can see whenever something breaks in this flow of the pipeline, we get an error, and you can hook in at every step. So you can say, I do it from scratch, from the documentation. I take a Docker image. I use cached binaries. I download the image, just start debugging. And so you have many entry points for these kind of things, basically to show here's something to test your environment, your safety, potential safety application, and so on. And it's all then about elements, processes, tools, and documentation. We see this a little bit later. Well, when you look for Linux, in principle, I just did a quick grab in the net to check what kind of results do you find when you look for safety. So you can see there are many and people and companies involved. So we have Intel Mobileye, which is now Mobileye standalone again, which bringing really safety into devices. You find reports, how this relates to the IC 61508. Red Hat, Elisa, Canonical, Electrobit, Amlix is also part safety TY. They all give the one or the other way, and talking about safe Linux, safety Linux, sometimes confusing. It's actually just a QM Linux with enhanced feature sets. It's not really, even if they claim it's safe, it doesn't mean that it's really a safety Linux, but like the Elisa title says, it's enable Linux in safety applications. So you can also give a kind of argumentation that you have responsibility and higher responsibility for Linux. Right, this on this, For completeness, yes, Elisa is the prominent example of these days where the community meets. Before we had the SIL to Linux MP project, and basically this stopped 2019, and a lot of people from them brought in their knowledge into Elisa, and we are progressing since then quite well. Right, the Elisa project goals are, we check on the certification of Linux-based system with the things I just met with elements, process, tools. It's more of the enablement, and we want to see that the work gets accepted by open source community, so that when we do updates on documentation, we had some workload tracing, upstreaming done by Shua. We're doing this in the medical devices of Elisa, and they figured out, well, if you do analysis, you need to understand what's running on my system, how is the workload, how are those things triggered. So they used tracing tools to just check, like standard Linux tools, and then we say, oh, it's important how to read them, how to use them, what does that mean? And by this, there was documentation upstreaming into the admin guide, and we also consider to put more things under the admin guide. One thing which is under preparation since a longer time and slowed a little bit down is on the preempt RT parts, because when you talk to people, they say, yeah, it's nice that we have all these things about preempt RT into the kernel, but you can do so much wrong when you have the wrong configuration. You may have non-working scheduling anymore, which worked always fine, but then you set wrong priorities, you don't know what to do. So how to configure all these features, this is something which we're drafting and which we plan to get somehow also then into the admin guide of the Linux kernel, because this is still a quite small area within the kernel, so there's a lot of space to fill. This we also discuss with the kernel community, and standardization bodies is also that we get awareness with them, present, for example, at Exceder, or talk to UL, and have members from TÜV involved. So this is somewhere where we at least also try to train. And then the reference systems. The systems is a point. This is, if you have seen previous presentation, I love to mention this one, because assessing whether a system is safe means you need to understand the system sufficiently. I'm saying this because I have interested people in safe Linux which come and say, oh, I want to build my safe Linux product. So, okay, what's your industry? They named the industry, said, what experience do you bring? Are you an expert in Linux? Oh, no, well, we haven't done that much with Linux yet. Okay, but you're a safety expert. No, we're not a safety expert. So, okay, you're not an expert in safety, not an expert in Linux, but you want to build a safe Linux product. Good luck, better don't do it. You don't get full support from me. Come in, learn from the others, but you don't get a provision. Better go to someone who knows what it is and get it from there. And why it's like this, you need to understand the Linux part and also the system context, what is left and right, what are the microcontrollers, what are interfaces, do you have shared resources, what is the operation, what is your use case in there. And when you look into this, how it's in their system, you will figure out, okay, Linux has a lot of components, features, and so on. And these need to be evaluated all for safety, and what is safety relevant, what is not safety relevant, do I keep it in, do I throw something out? Maybe all considerations which you anyway have when you build a product, but now you add the safety part of it, and then you look at it and say, well, this was not written for safety. So therefore, you will definitely identify gaps which are in there, because Linux differs from a traditional safety-critical operating system. The safety-critical operating system is certified, very small, microkernel, as least things in as possible, fit for purpose, no configuration. So if you just set it up and in your mind and change, like what do you see with Linux, you have a very flexible, configurable ecosystem running on different kind of hardware with same resources. Your live images of things, if you just plug it in a USB stick, boot a system, you can boot it on more or less every single PC which you can find. This doesn't work for safety. I mean, safety image typically is made like this, that you do not even require an update because it's bug-free, and you just do it once and you're done. And so you can see this is a compromise. But also, then you would say, oh, let's go with the traditional approach, don't mess up with all these Linux things or other open source parts, but then you miss a strong ecosystem support, because you need to port this commercial OS from one chip to another, to another, to another. You miss libraries, you miss configurations, you have to develop, you need to get into market at some point in time. And this complexity grows and grows with the computation performance which we have. So you may figure out that the commercial RTOS which you're using does not even bring half or more of the performance of the Linux kernel. So you may do your pre-development, say, oh, let's try out if things work. Okay, this works quite well, so I can use my use case. I port it to a commercial artist and figure out, oh, this was certified many years back when all these features were not there. Suddenly your caches behave differently, your memory sizes the block sizes of memory are different, and all these kind of things can have significant performance impact. And then you say, okay, how do I get this forward? And will I now pay the company for all the things that they sell the solutions to many others, or may I invest in open source and getting this path forward? That's where a lot of our members also think about. And then they come to the limitations of it. Whatever we do in there still, we cannot guarantee that the system is safe, so that it's out. And we can also ensure that whenever you build something, that you really know how to apply these things and that how to run it. And you also we cannot create an out-of-tree module on Linux kernel tree, because I mean there's a continuous improvement, there's a continuous involvement, and in the past you would normally certify on a fixed version, and this is true for all the other open source projects as well. We're running, we improve, we're getting better, we're adding support, and this is basically the thing why you use all this. You get all the benefits, and a typical safety certification would say, you are now at this point, please do not update anymore, because with any update you need to have a change impact analysis, and then go to a recertification. And this is something which is heavily touched by, like Red Hat, Kconfig, I missed them in the list before. These are companies which deal with the idea, how do we update this thing? The Zephyr project, Zen project, they need to have something in mind how to update. And you will have to need something in mind to update, because if you think about Cyber Resilience Act, which is in EU, radio equipment directives, you have connected devices, they may be mandates to say, whenever there's a security fix, you have this amount of time, let's say, maybe if it's a long time, you would have to have it in a few days or so typically, but I think the EU says something about 3 months or so. But if you create safety critical systems, 3 months for recertification can already be very tricky. So you need to address this also with the commercial parts. And this is what our members do. So we have a bunch of different premium general members with Boeing as one from aerospace, but a lot of automotive parts as well. We figured out that it doesn't matter that much which safety standard you are, because the requirements are very similar. So we can create a bunch of blocks with artifacts and activities. And there is a set of more generic parts. So this is the working group structure with open source engineering processes, safety architecture, features in there. They all interoperate. We create a system out of it. We use tools to check things in there, like a requirements tool or a visualization tool for kernel trees, and so on. But a system, you may hear safety element out of context quite often, but there is never really an element out of context. That's the name which they put in, but it's always in an assumed context. So you make assumption, and these people who create a safety element make assumptions. They say this is the way how you should use it, with their use cases in mind, which they had, and that's what they call the safety manual. So you need to comply to it. And that is quite complex. You will see if you, I guess most of you will maybe run on ARM hardware. It could also be on x86, but just take the ARM example. When you take the CPU documentation, the memory, the bus documentation for the buses which are in there, and the memory part, memory management, I guess you end up with 25,000 pages of documentation. Not for the safety part, just for the normal documentation. So you can make a lot of assumptions in this field. And that's what we try to help a little bit with different parts to just get an understanding of the system. Where can you identify parts? So for the automotive, we had a Meta ELISA, which shows an example use case. For systems, we do this more on a wider scope with Xen and Zephyr. We show how to do system analysis with SDPA. We set up some tools for code analysis with Code Checker, for example. Had the upstream workload tracing. We had the RT Linux, which I mentioned. So, and where is an underline there, you can basically click on the slides and get to the documentation and links on this. And those all work group then end up in documentation with GitHub, G Drive, blogs, white paper. We have a seminar series, so the upcoming seminar soon on the Rust certified compiler. We are trying to get something also on code coverage coming up more in the May time frame. So if you subscribe to the lists, you will all get this information, or if you follow us on social. yeah, with the reference system, this is like how an architecture looks like, and Stefano was giving the presentation before. Actually, 2 years back, he was going to Austin presenting his kind of architectural results with the DOM zero-less approach, DOM zero in there with Deathfire. He took this from a real industrial use case, and when we started this, there was an ongoing discussion in AGL, which had a similar architecture. We came up with this architecture, and I guess you may find your architectures as well in there where you say, okay, I have containers, I have virtualization, there's an artist involved, and because the chips underneath just provide this functionality, and you will make use of it. And here we try to get the things in, and you see the icons of the different projects. And this was very important that we not take it alone, that we interact with others. So we have a very strong communication with the Xen and Sapphire people. We have the AGL part for interaction. We went to Sophie also to discuss with them about the cloud SDV Arc environment, and also with Eclipse Foundation. We had, for example, an organized panel for open source and safety at some Excedia events last year. And yeah, with Yocto SPDX, I mean, it's quite clear. So the SPDX part was also for a safety profile. We created the SPDX safety interest group from Elisa, but we said it's not the right place to talk about ASPOMs alone in Elisa. We need it, but the right place to talk about safety in ASPOMs is with the SPDX people. So that's why we have a special interest group there. The group meets Friday, also late. So for me it's so late. It's like 6 on Friday, and I don't like to work at this time. But the people are very committed, and for getting the US people in, it's also more in the late evening European time, right? And it's really all about, right, not sharing apples, but sharing ideas, because if you share the apple, you still have one apple, or hand over the apple, but if you share an idea, you in the end up have 2 ideas. So that's the nice thing. And this is important for all the challenges which we have. Right, this is OSS, you all know it doesn't behave like commercial software. This has benefits and drawbacks. Maybe we can take this in the discussion. What does it mean? Like having influence or having not influence on the people contributing. How does it stand for a commercial environment? Why were certain rules created in the standards? And also like the training part. If you look in the ISO, it says you should be trained. How do you figure out that the training is sufficient? Can you really say this person is qualified or not? And will you ever go to Greg Hartman and tell him, can you show me your C certificate that you have done some C certification, or I cannot trust your patches anymore? I mean, it's something that you need to keep in mind. Then even if you go for this and say, oh, I know that this person is doing work for years, so this person could get, maintainer rights, for example, or committer rights. Well, we had just the XZ case, which was mentioned also in the keynotes, where it's social engineering. So you have a person where you start trusting, how does this work for safety system? And this is something the ISO standard, for example, doesn't cover, because it comes from a commercial environment where they never considered such a case. And also in a commercial environment, I know a few management people doing kind of coming from a tier 1, going to an OEM, and 2 years later, they're coming back to the tier 1, so they got all the insights, right? So this is something also like an intrusion part. So these are elements which you can keep in mind for your safety part. What about if some person goes from one company to the other? You claim him as a safety expert, but he's still bound with the other company, and suddenly start to put in something harmful in there. How do your review things get in? So these are all elements. The pre-last point I really like is the liability of a community, because a lot of people buy also commercial software because they would get away of liability. And the community typically is not liable for this. So we don't come with a liability clause or so you are getting responsible. And I find this quite interesting to be considered, that you as a company don't want to take the liability to certain parts of your product, and you better give it to someone else who is willing to give this liability. And what does this imply? Does it mean you don't trust your own projects? Does it mean you do not trust your own competencies? And this said, I was talking to developers where I said, oh, this sounds great. Would you be willing to commit this in an open? And then they came out and said, well, you know, I'm not feeling too confident. I have the feeling it's not good enough for the open source. I said, well, how can it be not good enough for open source? Because they had the expression like it's getting exposed, right? Other people look at it, they see, and if you then feel comfortable, and like everybody can see my code. Am I really good enough in coding? And then it would become, but it's good enough to create products for your company, right? This is like the same argumentation where they say, is open source quality really higher or lower, or can I take the risk? What does it mean if I go open source? It's all a world of hobbyists, which is, we know it's not. But this is the argumentation, which you also have the safety argumentation. And taking this all in, I conclude with my last slide as soon as it wants to change again. Here we go. Yeah, all the mentioned projects which we have in there, they are there with a just show up policy. So you can just go there. You can start asking questions. You can bring in use cases, ideas. We form domain-specific working groups which have special focus topics, or we do some like task force teams which just go through topic, ramp them down again. You can share best practices because this is all in the idea of safety. And if we are creating safety systems or just give guidelines, documents, and so on in the open, this can become a best practice. And actually, these ISO standards which you have, or IEC standards, they're there as best practice, state-of-the-art development. So if you go to court and get sued and you have a law case, they typically look under these, have you followed certain guidelines? Are you doing state-of-the-art? If we in the open show better practices than a product would do, let's say you're doing all your Linux, Sapphire things, or normal RTOS part on your own, inside your company, in a closed environment, and someone figures out later on at the case at court, you know, you haven't followed this. These guys were using an STPA analysis, and with a system theoretic process analysis, you would have found out that your architecture was wrong because they had a similar case and showed it already. Then you were not doing state-of-the-art technology, and then it doesn't help that you have certified, because in the open there's enough material available which shows you that the standard is not enough to do. So these are the things why to discuss more in the open for the better, for the safety of the people and the products. So let's tackle the challenge together, and we can enter into discussions, I guess. Just to have mentioned, I have all the links and entry points to the different projects at the back. So you could just download the slides, and now we can have a discussion. Anyone wants to kick off?
Obvious question is there a roadmap for the next year or something? I mean, particular goals for the project, or is it just being driven by what volunteers are willing to contribute?
Yeah, regarding roadmap, it's basically what's brought in. We have, for example, the June workshop where we also set up one topic where it says what the roadmap of our members, what are really pressing points where we should focus on. But there are some parts which we definitely can say. So we're scaling currently with the Basil tooling. So there's later the talk from Luigi saying about it. So we set it up. We want to bring it to life so that people can really use requirements tooling for focused on Linux part. This is in there. We are currently creating a roadmap on the Linux features again, where to go next, where to look first. I forgot what we wanted to touch at the first topic. I need to check in the slides from Alessandro. I don't know what he had. Gab, if you remember what was the first one, I don't know. But we start getting there in a little bit of agenda, what are the features which we are looking at. And so we have little minor steps. The documentation on a proper, like you go there on a wiki or a GitHub or so and just see what the roadmap is. This is not directly visible as such. So it could be that we end up as a workshop in June again for the next year's roadmap part, and then make a blog post out of it so that you have a tracked record of it. Yeah, the other part which we are looking in is to try to get a proper use case for our system. We have the example system. We've just showed it at Embedded World that it's there, and it was a very boring system. So I showed it to my manager. They wanted to see it, and I had this case, and I opened it, and I said it booted. You could see a command, and I said, yeah, that's it. Where are the things? I said, here you are. Oh, I can start another guest. See, here's another guest VM.
Yeah. So,
And like, it was nothing for management, right? And I said, oh, I also have, here, we share an Ethernet device. What's the use case behind it? And this is where we will look into, like, how can we get a use case? Who's willing to share design documents, architectures, or just bring in the commitment to say, I also drive a certain use case forward. We were considering, for example, the electric vehicle charging stations. There's the LF Everest project, where they have safety critical parts, which they typically do on their own, on microcontrollers or so it's not in there, and they have a lot of QM parts. But we say you can also put some safety responsibility in this charging infrastructure where they also have real-time regulation. So we say we put certain things on Xen, we give a little bit of responsibility to Linux. We also, for example, evaluate what does it mean when your QM system really interacts heavily with your RTOS. So you have the RTOS which need to fulfill part, but you may want to get information from the RTOS on charging parts, how long will it take, and so on, sensor data. What does it mean? What is when an attack comes? Is the system still safe? And these kind of things we try to get as first use case idea, but we need also the people who commit to it. Yeah.
Philip, I want to add on top. I mean, yes, I mean, what Philip explained is, the technical roadmap, in terms of activities that we have planned today. I want to chime in also from in terms of how is this roadmap defined, and we have strategic goals that are defined by the governing board that, where basically premium members are, those that can drive, and define these strategic goals. And the strategic goals are then, digested basically by the technical steering committee and are translated into a technical roadmap. So just, to give a bit more, explanation on the process.
Yeah, and this goes also on wider things, and also, I mean, this is something where we also discussed for roadmap topics. So say, how do we generate new input? How do we get these parts? So our workshop in Lund, for example, is also, it's considered for members, but it's open for non-members. So if you bring in a good topic, if you would like to get into a discussion, if you have a proposal on this, we're quite set already with the agenda, but these kind of things can also get in. You say, well, I'm interested, but what I can also say, if you just go there and say, I'm interested, but I have nothing to share, you need to be a very attractive company that I say, okay, yeah, that's the point to get in, because these projects, you see it and you know it most likely if you're working in them, there are many, many members, but it's also a bunch which basically follows. I have this in the automotive industry specifically. That's where I come from. I know so many people who say, we become member, that's an important initiative, go there and follow what's going on. And then you have 20 people in the room, and 16 of them are actively following what the 4 people say. And then it looks like there are 20 people and 4 people working, and then things become quite inefficient. There would be much more if there's more commitment in there. And there we are fully open, so also to bring in topics to lead work groups to drive forward. So our Linux feature work group is led by Red Hat now, but there's a co-lead who is just an individual. So he's not from a company or so. He just showed interest, brought the right capabilities, and therefore he became the co-host of the Linux features work group. And that's also how we approach things, quite open and active. The more points, some related industry, someone from medical with a good use case. This would be something which is still of interest. So we had, I'd say that I didn't touch medical, but we had the open APS system, which is, I touched it actually with the workload tracing. But there was the open artificial pancreas system to have a glucose monitor and insulin pump, which was an open source project created in the open without any certification or so, just by the needs and demands of the people with diabetes. And they said we need to have something, and it was by Dana M. Lewis. She didn't wake up at night from the warning. So her family was warned that her glucose monitor was going, and someone else had to stand up, and she was annoyed by these kind of things. So what she did was that she put a Raspberry Pi to her glucose monitor and controls her insulin pump. And the Elisa project took this use case and did safety analysis, looked what are the parts in the system, what does it mean, how do we operate, what subsystems are called from the Linux kernel, what are the syscalls which are done. And this was quite broad to the end, but we also said it would be nice to get this kind of example more from a real medical, not that the other thing is not real, but from an industry case to also better understand the medical demands. So this would be a topic which is, for example, of interest to us. Or we mainly covered IEC 61508 parts, ISO 262, the aerospace parts. We don't have the industrial standard. There are also industrial safety standards that are very interesting, like for operation of machines. If there's an expert on this and can share ideas, how things, this is also something which is very valuable for the Elisa activities.
Hi, hello, Philip.
Hey.
So I'm wondering, there are a lot of other working groups regarding to SDV, SOA, AutoZAR. They are growing, they pops out. So for example, like Eclipse, there is a working group inside Eclipse, which is specific targeting SDV.
Mm-hmm.
And I'm wondering, is there any collaboration between Elisa with Eclipse and other open source project?
Yeah, it's actually.
Yeah, and I have Googled it. The first thing pops out is your proposal, which is declined by EclipseCon last year. Yeah.
Yeah, so I give a statement to the decline proposal first. Even contributor from EclipseCon, so from Eclipse ecosystem, were declined there. So that was very funny. I was talking to one of the Eclipse SDV person and say, oh, you didn't want to have me. And she said, they also didn't want to have me. And this was quite surprising. So she was contributing to the Eclipse SDV in the ecosystem for the SDV track, but they didn't find a spot for it. That's the one part. We also said we need to align better, because I sent an invitation to the SDV workgroup lead to say, come to our workshop in Lund. I said, oh yeah, this sounds great. By the way, I also wanted to invite you to our community day to our, I think it's Friedrichshafen, I'm not sure where, somewhere in the south of Germany. Oh yeah, that's great. When are you planning this? 4th and 5th of June. Oh yeah, we're doing the same. Damn it, right? We completely had an overlap. Last year in October, we had the workshop in Munich. We invited the SDV people, but they had the EclipseCon in parallel, so they couldn't just come. But we find a way around, and we met just after EclipseCon and after our workshop at Spitzingsee at the Exida Symposium, and had an open source automotive panel there. So we were doing a joint activity, and we will increase this. So I started discussion that the Eclipse SDV group, they look on how to work with libraries, components, what to do from an open source component perspective, to certify, to do testing, what are the processes needed for it. Things where Xen, Zephyr, Elisa discussed since years for much harder topic than a single library. And so we will continue this discussion and bring a closer collaboration to this. And I also would say to the Eclipse SDV, the collaboration is closer and stronger compared to Sophie. So for Sophie, we've also been in discussion, but we haven't so close relationship because, I don't know. Basically, maybe it's from the ecosystem because it's good from the time zone perspective and all these kind of things. Yeah.
Okay. So the question following is, so you guys are working on the kernel side, but there are a lot of other, relatively small projects. They might be working on something like a communication bus or a specific application, something like that. Yeah, but how would they to interact with Elisa, and so to what extent you can give a suggestion to those projects, because I see that the safety and the security issue is really matters while you start designing your own project, and you need to consider your those tips from Elisa.
Yeah, you said we from Elisa look into the kernel, and we have a strong kernel focus. That's right, but we also mainly concentrate on the kernel side because that's where we can spend our resources and engineers which we have. Our member companies, of course, look into a much wider scope. They look into the related libraries, they look into open source components, and this is exactly what SUSE, Canonical, Red Hat, CodeThink, Electrobuild, Wind River, what they all do. They look into the wider system and they bring in these parts. So they also say, here's a certain commitment, here are parts. What we still try to also bring forward is to ramp up the collaboration with the CIP project again. So that's one Gab was talking about strategic goals, and we said one of the strategic goals for the roadmap is to get in touch again with CIP project, Civil Infrastructure Platform, because they run an industries environment with long-term support. They made ideas up on how do I configure the kernel, what are my essential packages which I need. So they have a set of 10 core packages, a high extended set of 500 packages. And if you start from a standard Linux system, you will not talk about 100 packages, right? You will talk in the thousands packages. If you download your Linux flavor of choice, I think it's for the Red Hat case, I saw the numbers, there's like 25,000 packages in Fedora, I guess. Then it's 5,000 packages for Red Hat Enterprise Linux and 500 packages for the automotive side of it, which shows you break it down. And if you have ever built an automotive project, you know that you will get down to 100 sets of packages and libraries. And when you build up a use case, that's also fitting to what you say. We were looking into the complete parse from showing graphics, capturing maybe with V4L2, and so we go through the stack of the elements. But the main focus, yes, is still on the Linux kernel side because that's where we have a common set across use case, across companies. So that's basically where it is. And then it's the capacity limit of the project size which we have. Yeah, good. We can have one or two more last questions because it's break time, and I don't want to keep anyone away from break. So therefore, just said, let's take one or two more. We're officially at the end.
My question is, how do you deal with testing and documentation mostly in open source and safety? Like when you have a new patch, because the idea is to continue improving, when you have a new patch, do you force the person doing the patch to create the specification of the patch and the testing and documentation? Or how do you deal with that?
This will not work most likely. So we hope that we can address this also in Vienna this year better in Plumbers. It starts also maybe in other parts where you just improve starting with man pages also and identify what are safety related, non-safety related part of your kernels. As you, first of all, from the whole patch set, you identify what are critical patches and then see how do we can, with limited or no impact, start getting traceability and see where are the things, are there regressions, what are the testing results. That's why we have PDX ASBOMs involved while we do certain. I mean, what we just show is just limited testing. We just basically have a QA pipeline with one or two tests at the end to just get the pipeline flow through. But this is, I guess, also one of how good you deal with handling the patch set. This will be a differentiating factor. And what we discuss in basics, and like that's how it could look like, but we haven't brought this also in the full Elisa flow yet. And we also rely on what the member companies do if they all come together and say, let's bring this as a new topic. That's the point, but they do exactly what you say. They check each patch and see how things go, what is related, what not. Can I just do the update? Do I need to do the update? Do I need the patch? And this is what makes it expensive and costs time, and therefore they're working on flows to automate and make it more efficient.
If every company is doing the exact same work, it's just, that's the point of open source.
Yeah, and I guess it will be a process, I guess.
Okay.
It will get more centralized and you figure out, I mean, that's why you have distributions. That's why you don't build your own system, why you have CVN, why you bring things to maintainers and so on. Yeah.
Okay, thank you.
Hey, thanks. Last question.
So I noticed Boeing is a premier member of the Elisa, and it's a company that's kind of under the microscope for safety and critical systems. However, there's not too many major companies in aerospace, and so having the code kept within the company is a pretty easy thing to have within some aerospace companies. How much of the community is able to collaborate, review with those major players, specifically like Boeing as a Elisa member?
Yeah. So, I mean, Boeing they started the work group, they have the aerospace work group, and they were really looking, and they say, we're open to everything which flies. That was one point. They said, that's not all where the safety standards for Boeing are exactly to be taken, but they say, we can also have smaller flights, we can have drones, or things which go potentially into space, even if they don't have, so they are opening this. And they were really like saying, okay, we have certain challenges. We see that we would like to make wider use of Linux system, maybe in the cabin part or non-cabin things that was mixed up with what. But from like where you can do parts, how you can increase the safety levels. And then, for example, Wind River, who is in there, they are also doing a lot of work for avionics and aerospace. So actually this week, there is Olivier, and he gives a presentation talking about Elisa and the activities Wind River are doing on an aerospace conference. So that's where they collaborate, and where then Steve, who leads the aerospace work group, and I were in close alignment with Olivier to see that we are talking about the same thing, that it matches the parts, so there a collaboration is possible. And it's really also that I've been in discussion with a research institute which works closely with Airbus, and we will also have follow-ups. Maybe they come to the Lund workshop to also bring in their thoughts, because they share their ideas, what they're doing, and they're so close to what also Boeing does. So they are sharing the same problems, and they don't want to have this differentiating part with, well, I manage to maintain packages. That's not differentiating, it's a must-have. You cannot sell this to the customer, maybe if you're alone or so, if you build but it's also not a selling point for it. It doesn't make your aircraft cheaper than when you do all the things on your own, and that's why they would like to collaborate. Oh yeah, Chuck, I didn't see you. I was looking for you at this side, so otherwise I would have said, Chuck, answer the question.
I work for Boeing. I'm doing a presentation here later, and I'm on the Aerospace Working Group Committee. Steve Vanderleest runs it. He's really good, way better than I. I've learned a ton. I think you're asking, like, are we developing out in the open so the world can, like, see for themselves? And to a certain degree, we are. Okay, we're using Yocto. That's not a secret thing. I gave a presentation on it at OSSNA last year. I'm going to do another one on safety critical stuff this year. It won't be on Yocto, but trying to introduce some new things in the lexicon. So there's always going to be proprietary elements. Obviously, we can't disclose because we're a profit-making entity just like anything else. We need an incentive to live. But that doesn't mean we're not subject to a lot of regulatory forces that force our nose to the grindstone to produce other artifacts. From a professionalized development environment like you can imagine Google has, we have to take that a step further. And there are systemic processes and things we do. You can squint and see those in every other safety critical discipline. There's a foundational element that you see coming out there's a foundational element in what Boeing does and what is flying that you see coming out in Elisa, and hopefully as the years progress, more contributions to the Yocto project. So you'll see those things occur out in the open going forward.
These were nice closing words.
Thank you.
Thank you, Chuck. So we finish here.
Looks like it's 11 o'clock. Go ahead and get started. Hi, my name is Andrew Opelt, and today I'm going to be talking about measuring code coverage of the Linux kernel in accordance with DO-178C considerations. So if you're not familiar with a lot of the terms in that title, that's fine. I'm planning to introduce both code coverage and DO-178C, so hopefully you can leave here with at least understanding those with some basic detail. For a little bit of background, for some context, I work for Boeing, and we're actually looking to use Linux in a number of safety critical applications. However, as it stands today, it's not really possible. So code coverage is just one of the many hurdles that we need to jump over in order to use Linux in avionics software. So, quick overview. We're going to talk about what the safety standards are, why discuss code coverage at all, the types of code coverage that there are, because there's a handful of types, what tools exist today to measure those, and then some work that we've done with the University of Illinois to actually enhance some open source tools to do this for us instead of the commercial tools. And then a little spoiler of what tool that is, but talking about LLVM Cov today and where we see it going in the future. Yeah. Champaign. So to get started with software safety standards, the primary one I'm going to be talking about today is DO-178C. And that's the fundamental one for avionics software, for commercial avionics software. That's used both in North America by the FAA and in the EU by EOSS. So when you're talking about certifying safety critical software in the avionics industry, that's really what we're talking about. And DO-178C defines 5 software levels or design assurance levels. They're called DALs for short. And these 5 levels define a number of requirements for how you need to develop your software and how you need to prove that it's safe. The categorization is based on what would happen if your software were to fail. So if your software were to fail and it would cause a catastrophic event, that software needs to be developed to all of the requirements for DAL A. And then those requirements slowly get lifted as the software is less safety critical, all the way to DAL E, where there's no safety impact. The way I like to picture various ends of the spectrum are, for DAL E, think about like the in-cabin entertainment, right? If this were to fail, there's no safety impact, the plane can fly fine. You might have some angry customers, but other than that, you're good. All the way down to DAL A, where we're talking about the software that's controlling the actual flight of the airplane. So the flight surfaces, the engine, and so on. Most modern airplanes and cars now are fly-by-wire, meaning when the pilot is using the controls in the cockpit, it's actually sending an electrical signal to some software. That software interprets those signals and then makes a decision based on it to control the actual flight surfaces. So that software is often what we're talking about when we talk about DAL A software. And that's just opposed to sort of the legacy way to do it, where when the pilot would control something, it would be physically connected to the actual output. Additionally, I'll just mention it here quickly, but the Department of Defense has its own standard, MIL Standard 882E. It defines 5 levels of rigor, and it's no coincidence that these map very closely to the 5 DAL levels. So the Department of Defense, obviously the Air Force and the Navy have a number of airplanes, and they use similar standards. So why discuss coverage at all? Well, depending on the level that you're developing your software at for DO-178C, there are a number of coverage requirements. So at DAL D and E, those less safety critical ones, there are no coverage requirements at all. However, when we get into A, B, and C, which is often called safety critical software, there are requirements added. So for DAL C, you need to do statement coverage. For DAL B, you need both statement and decision, so it's additive. And then for DAL A, you need statement, decision, MCDC, and object coverage. And on the following slides, I'll be going into detail about what those different types of coverage actually are. So why is coverage important? Well, at DAL D, where there are no coverage requirements, the primary focus is really on reliability, which is to say that the software does what's required of it. And you just need to prove that. However, at DAL A, B, and C, we're additionally focused on safety, which means that there's no unintended or untested functionality. And code coverage is one of the tools that we can use to actually find that extraneous, that untested or unintended functionality. So I give this clock as just a really quick example of what unintended functionality might be. So if we have a single requirement for our software system, maybe we're just displaying a clock in the cockpit, and all it needs to do is display the time of day. This clock would be fine if it were assessed at del D, because it displays the time. We have a requirement for the time, and we could test the time. However, if this were a del A, B, or C system, this has extraneous functionality, right? It displays the day of the week and the date. So that's the type of thing that we can't have. We can't have that extraneous functionality. And obviously, this example is trivial, but when you look at something like the Linux kernel, which is huge and it's not always transparent what all the functionality is, code coverage is one of the tools that we can use to find areas of the kernel that we may not have tested or that we may not intend to actually be there. So talking about the different types of source code coverage, I point to this really simple example here. This is C code. There's a struct. It has 3 fields for hours, minutes, and seconds. And then there's a single function which tells you if it's valid. So it tests to make sure that the hour is less than 24, the minute less than 60, and seconds less than 60. So the first type of code coverage is statement coverage. This requires that you test every single statement or every single line in the code. In this example here, there's just a single statement. It's the return statement. So in order to get 100% statement coverage of this function, you just need to call it. It wouldn't even matter what the input was, whether it's valid or not. You're going to get 100% statement coverage of this function. And statement coverage is required by del C. Next up, decision coverage. So decision coverage requires that you go and you look at every Boolean decision, and you verify that each decision is tested, and that you make sure that it's evaluated to both true and false. So now you're starting to test more of the edge cases in your code. So in this example, there is additionally just a single decision. So the decision is checking for the validity of the input. And to get 100% decision coverage, we would need to test this, most likely in a unit test or as part of a larger test, with both a valid and invalid time struct. That would cause this Boolean expression to evaluate to both true and false and give us 100% decision coverage. So for example, if you ran your test suite and it showed that you only had 50% decision coverage of this function, you would know that you hadn't tested all of your scenarios. Next up, the last type of source code coverage, MCDC, or modified condition decision coverage. This requires that you look at the actual conditions inside the decision. So this decision here has 3 conditions. It has a condition for the hours, the hour check, the minute check, and the second check. So MCDC coverage requires that you go and you look at those individual conditions, check that they evaluate to true and false, and then show that they independently affect the outcome. And on the next slide, I'm going to go into a little bit more detail about what that actually means. So I said that you have to test every condition, and you have to show that it independently affects the outcome. But what does that actually mean? I think the best way to show this is to look at a truth table for just a really simple decision. So the decision A and B has the following truth table. And the way that we show that condition A independently affects the outcome is we fix everything in place, give it an assigned value, and only change the value of A. And when we do that, we need to prove that the result changes. If we can't prove that, then we can't show that A independently affects the outcome, and it must be an extraneous condition inside this decision. So if you look at the first and second line of this truth table, B doesn't change, it's fixed at true. However, the value of A changes from true to false. And that actually causes the result of the decision to change from true to false. So these pair of truth table entries, and it's always a pair because it's a Boolean, so it can be true and false, these pair prove A's independence. Additionally, for B, we can look at the pair where A doesn't change. So the first and third row, A is true, only B changes, and the result changes. So those 2 pairs actually prove B's independence. And it's often written like this, where we say that the pairs true, true, and false, true show A's independence, and true, true, and true, false shows B's. So MCDC really dives into the conditions and makes sure that you're testing all those different combinations. So next up, oh, sorry, go ahead. Can we ask a question? Yeah, go ahead.
Yeah, so based on what you presented at the slide earlier, what phase of the development that you do the testing?
Sorry, could you repeat that?
Yeah, what stage of the,
what stage of development?
Yeah, so it looks like it's a development, a coding time you do the test right now. And also you need the access to the source code, and you have like 1 million lines of code.
Yeah, so this is actually one of the huge challenges. So right now we're working with Linux, which obviously all the code already exists, or it's changing, but there's a huge code base. So we're looking to go in and apply source code coverage to the existing code with our tests. However, generally, if you were doing this in a forward development situation, you'd want to do it all at the same time. So you'd write your code, you'd write your test to go along with it, and then as part of your CI/CD pipeline, it would generate the coverage for you. And if you have high coverage, it doesn't necessarily imply you have good tests, but it implies that at least you're testing all the functionality inside that code.
So at the end, my coding phase, do I need to go to the testing phase with this?
I would say, yeah, in a traditional waterfall sense, that's how you do it. But in more modern times, it's usually tied together. Like you'll write code and test at the same time.
No, for DAL A, it requires independence. Developers aren't even allowed to do their own testing like this. It has to be a separate, provably independent group that does the testing.
So,
yeah, that's a good point.
If you do this kind of thing to do the testing, you have to access the source code.
Yes. Well, it's got to be an independent group that does the testing. So developers do development. You have a separate test group that does the testing. They come up with the test.
He said that differently a bit earlier. Okay, that's fine.
So yeah, sorry for that misunderstanding, but yeah. Okay. So the next type of coverage is not focused on the source code at all, but it's focused on the object code, or actually the binary that runs on the target, or the machine instructions. There's a few different ways that it's said. The goal here is really to look into what actually runs on the target, right? So if we have source code on the left, I think we all know that if we compile this, we're going to get a set of machine instructions. However, the source code can remain exactly the same. You can change your compiler or your toolchain settings, which we've seen with some exploits recently, and you can get a different set of machine instructions. So object code coverage is really focused on making sure that you don't get any of that unintended or untested functionality inside the machine code based on things other than the source code. And so doing this manually by hand obviously would be basically impossible. So there's a number of commercial tools that have been available, and this is traditionally where teams at Boeing have gone to do code coverage. So they'll go to one of these tools. However, these tools have a number of issues. They're expensive, they're proprietary, and oftentimes they're not the easiest to use. So there's oftentimes training courses or onboarding, like huge onboarding times to work with these. And also there's a lot of getting stuck. When you go with one tool, suddenly that's the tool you're using. More importantly for me and for our team, though, we couldn't get these tools to work on the Linux kernel, and we weren't convinced that they would work. These tools rely on running on top of an operating system. Well, when you're actually trying to instrument the operating system itself, you need to do something different. So instead, we looked at open source tools. So Gcov, along with lcov for reports, is probably the most common one. It's part of GCC. What's great about it is enabling it only requires adding some compiler flags, and it supports statement and branch coverage out of the box. Additionally, there's LLVM-cov, which is part of LLVM or Clang. It requires just compiling with Clang, same thing, enabled with compiler flags, and supports both statement and branch coverage. However, if we're going to pursue one of these open source tools, there's a few problems or limitations. First of all, they're not qualified. And so qualification is really a process like certification where you prove that your tools are actually reliable, right? If you're going to use the output of the tools to certify your software, you need to make sure that your tools aren't just generating garbage. And this is one of the major advantages of the commercial tools. Additionally, these tools were developed in the community, not necessarily aligned with DO-178C, so their metrics don't always line up exactly to what we need for certification. Additionally, the coverage types of MCDC coverage and object code coverage just aren't supported at all. So the approach that we took was at the beginning of this school year, we opened up a university research project with UIUC with the goal of enhancing one of these coverage tools to provide up to DAL-A support. So that is, take an existing coverage tool, add in any of the metrics that we need for DO178C, and add in any of the functionality that was missing. And so far, throughout the school year, there's been a lot of great progress made. So they started out by profiling the Linux kernel and to understand what our problem space actually was. How many conditions, how many decisions are out there? What do we need our tool to actually measure? And obviously there's hundreds of thousands, if not millions of decisions inside the kernel. So it's quite a big problem space. We down selected to LLVM-Cov as our chosen tool. We felt like it was the most extensible tool, but additionally, there was an open merge request from the folks at Texas Instruments with initial MCDC support for LLVM-Cov. So a great head start. It didn't work perfectly, but we were able to work, and the university was able to work with those patch authors and with the LLVM community to add and enhance the LLVM support, or the MCDC support in LLVM-Cov, and get it merged into LLVM 18.1, which came out last month. So you can actually download LLVM, you can run LLVM-Cov on your code today and get MCDC reports out of it. Additionally, there's the challenge of the Linux kernel itself. So we can't just run LLVM-Cov as it is, because when it collects its performance data, it has nowhere to store it. It's running on bare metal. So there was an existing patch from 2021 that had been abandoned by Google to add in PGO, performance guided optimization support, to the kernel. And that patch was dropped because there wasn't enough support for it in the community. It was only really for optimization and collecting performance data, and the community felt like there was enough ways to do that already. They didn't need to do it the way that specifically worked with LLVM and Clang. However, the UIUC team has actually pulled that patch back. They've updated it, they've pulled it to the latest, they've enhanced it, and now we think that along with the performance metrics, but actually being able to collect MCDC coverage on the kernel, there's a good selling point for getting this patch accepted. And I think I saw some activity yesterday that they're working on the final steps before they submit that. So I imagine that'll be coming in the next few days. So along with LLVM 18.1 and then that patch, we were able to show that we could collect MCDC coverage on the Linux kernel itself and run through some of the open source test suites that are out there. So Kself-Test, Kunit, and a few others to see what it looked like. Initial reports of the kernel are those tests cover a very small part of the kernel. Like when we're talking about MCDC support, it's like 1%. So there's a long way to go, but at least we now have a tool that can measure it. Here I just wanted to give some example output of what LLVM-Cov looks like and what a commercial tool, VectorCast, looks like for the same inputs. So I took, and it's not here, but there's a simple C program. It has one if check in it, and it has this if check here, if A and B. And I passed the values true, true, and false, true to this function. So I'm expecting that I haven't gotten 100% MCDC coverage, but at least because I've varied the value of A, the first condition, that I should see at least MCDC coverage for A. And that does show up here. So when we run LLVM-Cov, we get a text-based output. You can also get this as HTML. LLVM-Cov points to and assigns names to each of the conditions. So here, condition 1 is the name that it gives for A. And this is a line and character number, which points to that. And condition 2 is the name it's given to B. And down here, it shows the truth table, or a representation of the truth table of what it saw executed. So the first entry here is false and a dash. So because it's an and, it's short-circuited, so the second value actually doesn't matter. But this represents the false-true pair I passed in, and then the other one was true-true. And with these two pairs, LLVM-Cov shows that our C1 pair is covered. However, our C2 pair is not. So we have 50% MCDC coverage for this expression. And on the right, it's the same thing with vectorcast. So vectorcast formats a little bit differently, but you can see the same things here. It's assigned names to each of the conditions. It uses letters as opposed to numbers. And then it prints out the truth table here with asterisks on the rows that were actually hit. So where does that leave LLVM-cov today? So LLVM-cov has a number of advantages, even just today, which is you can run it very easily, right? You just add compiler flags to your build system, and you can get MCDC support out. There's no graphical user interface you need to mess with. It's configurable and extensible, and I'll talk on the next slide about some of those extensions that we're planning. And there's no license costs. Easy to integrate into CI/CD. This sort of goes along with the previous ones. So the basic idea is in your CI/CD pipeline, if you have any tests, unit tests or integration tests, you can add these compiler flags to your build. You can run those tests, and then with the performance data it generates, you can generate your MCDC coverage report. And the nice thing about that is that as you add new tests, you can see what code is actually being covered and how useful those tests are. And the big one for us is really we've proven that it works on the Linux kernel itself. However, there's still a number of limitations with LLVM-cov today. First of all, it's not a qualified tool, so that hurdle still needs to be jumped over. We have plans to qualify it, and similar to like how Zen was talking this morning, they're working on generating all the artifacts. That's really what we need to do. The tool exists. We just need to generate the artifacts in order to prove that the tool is reliable. It does not generate object code coverage, and it requires compiling with LLVM and Clang. So this may or may not be a limitation. Many people compile with Clang now. However, there's a bunch of tools in the ecosystem which just assume GCC, and so they don't always work with Clang. So we have some patches that we're planning to get all those tools to work with Clang. So finally, what's next? We made a lot of good progress, but the current implementation of MCDC coverage in LLVM-cov only supports up to 6 conditions at a time. And we've proven based on our analysis of the kernel that that's not nearly enough. So while this does cover the vast majority, there's still 20 to 30% that are more. So we think we're probably going to need to double that, at least to 12, maybe a little bit more. And we're investigating, what's possible. There's some constraints there, right? Like a truth table for 2 items is small. A truth table for 6 items gets a lot bigger. When you're going to 12 or 18, suddenly it's intractable. And so we're running this as part of the kernel when we're instrumenting it. We need to make sure it actually works with our use cases. Additionally, there's decision coverage. So LLVM-cov only supports branch coverage. Branch coverage seems like it might be decision coverage, but it's a little bit different. So decision coverage is really taking the whole decision itself and seeing whether it evaluates to true or false. Whereas branch coverage looks at the individual branches in the code, so all the, the jump statements in the assembly. And those don't always align one-to-one. However, the team at UIUC has actually put together a patch. It's in the beta state, I'll say. It works, but we haven't tested it extensively, to generate decision coverage from LLVM-cov. And that's really based on the work that was done for MCDC coverage. So for MCDC coverage, you have to identify the whole decision anyways. And we think we can reuse that in order to generate decision coverage. Our plan is to finish testing that and then upstream that patch, depending on whether there's community support for it. So decision coverage is pretty specific to some of the safety standards, so we're not sure if it's more widely applicable. Additionally, there's object code coverage. And this is really our big next thing to tackle. And this is what we're going to focus on throughout the next year. So object code coverage, in a lot of the tools, it doesn't give you a lot of useful metrics. It's often difficult to read. It's often difficult to use. So we're looking at how we can actually use LLVM-cov to generate object code coverage. We've done some initial, very early tests and proven that it is possible, but we still don't know what this looks like, and there's a lot of work to be done here. So with that said, that's what I had today. Thanks, everyone. Do you have any questions, any comments? Yes, we have tried it, and we've. Yeah, we've actually run. The question was, have we tried this? And yeah, we've actually run it on the Linux kernel. So on the kernel. Yeah, we've tried it both in an emulator in QEMU and on bare metal. And we were able to collect data based on some simple tests like K-self-test, K-unit, and a few other just open source test suites.
How big was the kernel that you deal with at the time?
I'm trying to remember the configuration we used. It was a smaller kernel. It wasn't like just a general purpose one, but it wasn't all no. It wasn't like the tiniest that you could get it.
Because I have used some of the tools, and it takes a long time. Especially when you get into the object arena, then even with the current processing power, it takes overnight.
Yeah.
Very little object.
Even the source code-based coverage does slow down the process a fair bit. LVM Cov as it stands now, it will work, and we've actually proven that it will be suitable for running tests on. But yeah, we haven't gotten to object code coverage yet. So there are some concerns there with performance.
So you can do it.
Yeah.
You can do that, but it would take a long time to run it. And you need to come up with a new algorithm. Yeah, new algorithm that I did the research on that, and I provide the algorithm, and the people use that, and they spit up, I don't know, big percentage. I don't want to disclose that.
Yeah, okay. Appreciate it. Thanks.
All right, I got a question for you. I'll lead the witness here a little bit.
Okay.
So you've heard the phrase, racing improves the breed, right?
Okay.
So all this work that's being done by Boeing, can you speak to a little bit, if you're prepared to, like how does this benefit the rest of the open source community, even people not in the safety critical world? Why would they care?
Yeah, I think the testing is a good example. So there's a lot of test suites that are out there, and people write tests, they do their best, and they try to test the things that they can, but it's often not clear like what the tests are actually testing. And I think coverage data is a good way to view, when you write a new test, what actually happens, like what are you actually hitting? The other one, which I think is interesting, is the object code coverage. Object code coverage will show things where like there are supply chain attacks. If somebody puts in a merge request and says, I'm just updating the documentation, I'm just reordering the build scripts, and all of a sudden you notice there's this new object code that's been inserted. The object code coverage, I think, would be a great way to expose some of those things. So I see its use in security as well.
Also, it's worth noting that, if I'm not mistaken, I think it's SQLite. They actually have MCDC coverage built into their code base.
Okay.
I think it's the only one, if not mistaken. No, okay, I'm getting a little. Thank you.
For the SQLite, they have MCDC coverage, but they don't try to get to 100%. Because they found they prefer having robustness code to avoid bugs that is just untestable with MCDC. But I'm not involved in any way, it's just from reading blog posts.
Yeah, that's a good point. So like testing for coverage is one thing. Testing for robustness and having good tests is another thing. And they often intersect, but they're not exactly the same thing. So you can write a really good test that gets great coverage. You could also write a really bad test that gets good coverage. However, if you're writing good tests, you're usually getting higher coverage. So there is some correlation there.
And I have a question. Why did you choose exactly LLVM Cov instead of Gcov, for example?
So part of it was that the MCDC support had been started. Part of it was also we were looking to move to LLVM and Clang if we could. We thought it would be easier to implement a number of things outside of code coverage in that ecosystem. But we actually thought when it came to adding object code coverage that would be easier. Because you're right, in a lot of ways, Linux and the kernel is already set up for GCC. It's really easy now to collect coverage with GCC and Gcov. So we just felt like the trade-offs were worth it there.
Thank you. I have a question. Do you plan to also push tests upstream, like in key self-test, key unit? indeed, measuring coverage indeed is great, right? But if we extend, the baseline of testing that we have available upstream, I believe, and also if we maybe improve the quality of the tests themselves, right?
Yeah.
That is, I believe, where we have the huge, value for the whole community.
Yeah, so we do have plans to push upstream the tests. I think the one thing we're not sure of, and we probably wouldn't push upstream, would be like requirements or other architectural documentation. But the tests and the code changes, like if we were to find any issues or redundancies based on our analysis, those are the things that we would push upstream. And I think we're in the process of doing that now. So like we've written some runtime tests that run through BitBake, and we're planning to upstream those soon here.
Okay, thanks.
Mm-hmm. Okay, no more questions? Thanks, everyone.
You did a really good job. I saw the presentation's really good. So young. Rising star in bow. Looks like a steam. I was looking him up on LinkedIn. I couldn't find him. Yeah. A lot of these people that don't have a LinkedIn profile. So where are they going? Can't hack them, right? I know. Twitter for even less people on Twitter. Yeah. found you.
Okay.
I work at Linux Foundation, so I have access
you're
to a
very
lot of the information.
Are you local?
I am not from the Midwest.
Okay. The fact that you know about that restaurant is, I was surprised.
Yeah,
Okay.
because it's a chain, right?
Yeah.
I've eaten there in San Francisco
Right.
a couple times.
Yeah.
Yeah.
I'm
Cool.
from Seattle. I've been to that one.
Okay, yes. So I just sent you an invite. So yeah, join us.
I'm receiving, so the black dot is approximately where my house is. You can see it there. There's a lot of terrain. So All right. Let's uncork the bottle. So it's kind of like the map you just saw, looking at the fishbowl. That red pin is approximately where we are right now. This funny-looking peninsula, in 1999, I was riding my bike with my father in a town due west of this peninsula called, where we are, called Silverdale. Okay, went to high school there, went to junior high there. I know the area very well. I found myself 2 feet away from a light truck that had just shot some form of steam, gas, I don't know what it was, into the passenger compartment, and the driver was diving out of the car as fast as he could. Not 30 seconds later, this light truck was fully engulfed in flames. This thing happened faster than I could even realize. We're all just stunned looking at this. By all accounts, the truck didn't look beat up. I was a young driver, so I'll say that this guy was an older gentleman. It didn't look like he was a teenager throwing the car around. By his account, it was just his daily driver. He kept it maintained. But this car just burst into flames all of a sudden at a red light. That was horrifying. You had to be there. Most likely, more likely than not, that was a failure of safety engineering. Okay? And that's what I want to talk to you about. So who am I? My name is Chuck Wolber. I hold a BS in mathematics from Washington State University. You'll find me in the contributor section of a lot of the early editions of the Red Hat Linux Bible. I am a co-author of a book called Linux Toys. It's out of date, so if you want to get it, you can, but it's way out of date. I was big into the lug scene back in the day when it was big. We thought we were the scrappy underdogs. And I've been at Boeing for 20 years as a software engineer. I was inducted into the Technical Fellowship in 2022. And if you flew here on a Boeing aircraft, you probably had a Linux OS running on it that I had a lot to do with. So let's start with developing an intuition. That's where we want to learn all new things, start from a basic intuition. Think back to the first program you wrote, not Hello World. The first program you wrote, maybe you were a kid, maybe you came to it later in life, it didn't really matter, but something of consequence. And I don't believe you if you told me it worked, because I know it didn't, okay? It had problems. You didn't have requirements. You didn't have unit tests. You didn't have another engineer saying this broke. You just felt something wasn't right? 2 plus 2 did not add up to 4. Maybe it was that straightforward. Your line tracing robot didn't follow the line, or whatever it was, okay? I want to cement that intuition in your mind. Something ain't right here. Something doesn't feel right here. Another thing that doesn't feel right here. So normally I'll go to stock art sites to grab some stock art images to throw something interesting, because I'm not a wordy guy on slides. I like running my mouth more than I like putting words on a screen. But I decided to give OpenAI's DALL-E a try, because it can do some cool stuff. And for the most part, it worked out well. There were some fun failures, which I'll show you later on. But if anybody at OpenAI is either here at this conference or watching, I want to tell you how difficult it was to get it to generate an image of a kid debugging his first software program where the kid did not look like me, okay? It was like hard. It wasn't like, oh, try again. This is like 7, 8, 9 back and forth. And I finally had to like put my thumb on the scale. And I said, give it some feminine characteristics. So that, I mean, it should not have been that hard, okay? So I hope someone hears that. I know they're doing a lot of work to drive that garbage out of there, but if we can do some more work, it'd be better. It'd be nice if we could do that. So I just wanted to throw that out there. But that's also something ain't right here. This is just not right, okay? I did the best I could, okay? I'm still not satisfied with that, but I did the best I could. So it's a bug. That's what we're talking about. And a bug, at the end of the day, is just a violation of your expectations. The computer is probably not broken, okay? I know we'd like to blame it on a broken computer or bad compiler. The physical laws are consistent, and your computer's probably fine. You just expected something different. Garbage in, garbage out. Now that image there, some of you may be familiar with it. That's variously attributed to Admiral Grace Hopper finding the first bug in a relay and pulled it out. The internet ruins everything, of course. That is not attributed, it's not correctly attributed to Grace Hopper. That's not her handwriting. And the first reference to bug was found at least 100 years before even this came out. So just wanted to ruin that for you as well. But it's a cool picture anyways, and I'd always thought that was the first bug. You expected something different, okay? So we grow up, some of us are fortunate enough to be professional software engineers, and we professionalize around that intuition, right? We get unit tests, we get static analysis, we get functional tests, we get CI pipelines, we get IDEs that do a lot of work for us, we get languages like Rust with a lot of memory safety built in. We professionalize around this intuition. The intuition's still there, something ain't right, okay? But you've got a lot of tools that sort of drive that out. That's best practices, that's universal. You go any mature software organization, and it'd be weird if they didn't have that kind of stuff, okay? We're all used to it at this point. But there's another type of defect that we have to pay attention to. This is a safety defect, safety bug. This is a violation of expectations, just like any bug, but this endangers the user, puts them in danger. The physical laws are still consistent. Physics didn't suspend itself to abuse your carefully created system, okay? There is a violation of your expectations that endangers the user because the system is not working correctly, okay? The user was hoping for different behavior. I put an asterisk there by user because it's not always a human user, right? It could be your precious pet in the hold of an aircraft, and you are nervously hoping that environmental system keeps running the way you expect it to, right? Or it could just be another system in a block of systems that has been given bad input or is behaving incorrectly. So user is a very broad definition here, not just the human on the other end of it. So why is that different? Why does it matter? Why is it different? It's always system of systems, no matter where you go, okay? Nothing special here. Even when you're sitting there at your desk doing your first software project, it's still a system of systems. If we don't talk about your brain or the power company or anything like that, it's still a CPU, RAM, you got a hard drive somewhere in there. It's just systems of systems. In the terrestrial world, the ground world, the data center world, okay, you can brag to me all day long about how amazing your CI setup. Push on green. We've got these great unit tests. Everything is amazing, right? So why aren't you firing your SREs? Because it's not, right? There's more to it than that. You can't walk into a place like Boeing or an auto manufacturer and say, oh, I've got all these best practices, I can use them, push on green, we're good to go. Because when that backup camera has to start up in a half a second, 500 milliseconds, and show you a child running behind the car, okay? There is no time for an SRE to jump in there under the hood, debug it, fix it. You don't send someone in the electronics bay at 40,000 feet to pull logs. It doesn't work that way. So the system has to operate knowing that there is no intervention. You don't have to know how a car works to operate it. You don't have to know precisely how an airplane works to operate it. Yeah, if you're getting into the flight deck of a Boeing aircraft, you have spent a quarter of your life getting good at that. But that is tiny compared to all the information you would need to know. I guarantee the amazing pilots we have out in the fleet do not understand the boot sequence of the system I engineered. And they shouldn't have to. That's what safety engineering is for, okay? And that's why I have the discipline of safety engineering. You could probably squint and like, oh, I've seen that testing, I've seen this, I've seen that. This is a defined discipline with specific steps. Now I had DALL-E generate me a three-legged stool. That does not look to me like a three-legged stool. It looks like a four-legged stool with one leg hiding the other. So anytime it gave me one of those amusing errors, I gave it a "you tried" award. So it tried. This generally applies to, as I understand it, all of safety engineering, medical, automotive, definitely aerospace, aquatics, the whole 9 yards. You can break it up into 3 big buckets. You've got hazard assessment, you've got design mitigation, and you've got implementation assurance. Any safety critical system has to go through those stages. You have to identify the hazards. Once you've identified the hazards, you have to mitigate them. And then you have to prove that the thing shooting out the factory is an accurate representation of your design. So let's talk about those and the limitations. Let's talk about hazard assessment. A hazard is anything that lowers the margin of safety. And it is an entire occupation. I don't do hazard assessment. We have people who do hazard assessment, who do nothing but hazard assessment, because it involves an incredible amount of data, gathering information about past accidents, and that bucket is constantly filling. We never empty that bucket. It just gets more and more complex. You start with hazard identification, then you have to categorize how bad that particular hazard is, okay? A car catching on fire is a much worse hazard than a wheel blowing out, tire blowing out, unless you're at 60 miles an hour in the middle of traffic. Maybe they could be equal, right? So this is the very difficult job of someone doing functional hazard assessment. And then there's, of course, hazard likelihood. Alien abduction would be a catastrophic failure if the car was flying down the road with no one in it, but the likelihood is very low, I hope. At least we have no data on it that I'm aware of. So here, what are the limitations of hazard assessment? You guys familiar with this? Yeah, that's the Tacoma Narrows. This was not the original design for this bridge. The Washington State Department of Transportation actually came up with a really good, robust design, and someone had the bright idea to go with a cheaper design. Save some money. That savings is now at the bottom of Puget Sound. You can actually, it's very dangerous to scuba dive there, but if you have the right people to show you, you can go down there. I think it's like a park, and you can see the artifacts from the bridge that fell down. We never want to forget this. This is the stuff that fills these buckets and informs functional hazard assessment. We're never perfect, but we get better. So this boils down to unknown unknowns, right? You can't possibly know everything. And suddenly you're astonished. I didn't think that was likely. But it turns out your likelihood artifacts are terrible. This is more likely than you thought. That's why you need more data. So you're always going to have to work on functional hazard assessment. So you've done your functional hazard assessment. You've told your design team, here's the hazards you need to worry about. Now we got to show evidence of mitigation in that design. This is architecture and design. Depending on how critical, level of criticality your system is, the more architecture, design, and requirements decomposition you're going to do. I usually work on DAL D and E systems, okay? Not the really super critical stuff. And I have been told by people who worked on DAL A systems that the requirements definition has to be so detailed you could practically re-implement all the code just from requirements. The variable names might be different. Like, that's the level of detail you're talking about. We're going to put Linux in a DAL A situation someday. What are the limitations of design mitigation? What's that? That's Chernobyl. We knew about reactor meltdown. We knew about that, right? You see Oppenheimer, not Oppenheimer, but the Manhattan Project, there was a demonstration of a runaway reaction. Someone died from that, okay? We did not adequately mitigate that hazard here under the conditions that apparently are realistic. A lot of failures here, and it ended up as a disaster that to this very day is still being fixed. There's a giant stone cement sarcophagus being placed over it, over the entire reactor to block the radiation. Got another participation pin over there. Now let's get to implementation assurance. You've identified your hazards. You've mitigated them in your design. Now prove to me with artifacts that your design that's flying out of the factory matches, your result running out of the factory matches your design. Well, that's, your test program, right? We just heard from Andrew in the previous session about all the testing you have to do. Incredibly complex once you get down to MCDC. It's a fun problem, okay? And by the way, I don't know what DALL-E came up with there, but I want one of those really bad, because that looks really cool. So what are the limitations of implementation assurance? We identified the hazards. We designed in a mitigation for them, but we failed at the implementation assurance stage. Who is that? Yeah. What's he doing there?
Putting a rubber seal into ice water.
That's right. Okay. Morton Thiokol designed a seal for the solid rocket boosters that did not take into account the low temperatures the Challenger was going to be launching in. Gases shot out the side, burned a hole into the fuel tank, and the rest is history, leading to him there demonstrating in a cup of ice water the failure mode. Every engineer is like, come on, guys, right? So underlying all of this safety engineering, we have to work with two operational assumptions. We don't have a choice. We have to assume that the system is operated as designed. We must assume that the system is operated as designed. It is not being misused. We must assume that the system is maintained as specified. Those two are incumbent in all of our safety engineering decisions. Another participation pin up there. Okay? But what if the Newtonian physics that we've set up for our system are violated? What if the operational assumptions are violated? What if someone defeats the sensors? What if they override the lockouts? What if they get in there and void the warranty on our safety critical system? What if they violate social norms, kick in the wrong door at the wrong time? What if someone slips a vulnerability into the software supply chain? What if someone exploits a weakness? What if someone does not perform the maintenance as the manufacturer specified? And what if you have an unqualified person, user, at the wheel of this thing? What does safety engineering have to say about that? What if someone smashes our carefully designed system with a cinder block? In computer science, there's a problem called the satisfiability problem. And that means if I've got a Boolean equation, A and B, or A and B or C, so on and so forth, I need a way to tell me if that equation is ever going to be true, if I can flip the bits some way to make that equation true. So if it's A and B, it will be true when A is true and B is true, right? Conversely, if it's A and not A, there is no way for that to ever be true. So that's an easy way to do the satisfiability problem for a small equation. Once you get up to 100 variables, okay, as you know or may know, this is an NP-complete problem. There's no shortcut to figuring out if this is satisfiable. This long Boolean ands and ors and nots and all that, 2 to the 100th power. You're boiling the oceans at that point, right? Turns out, the P equals NP problem, all the NP complete problems, can be derived all the way down to the satisfiability problem. So if you want to win the Millennium Prize and be rich and famous, you just need to solve the satisfiability problem to solve this P equals NP, and you'll be rich and famous. That's the analogy I'm trying to make here. All the what ifs, everything that could happen to your carefully designed, all the violations of the operational expectations, always derive down to the cinder block problem. Because it always results in the same problem, which I'm going to get into here, okay? It's the baseline problem, and it's a dramatic vision. It's a dramatic thing. Satisfiability is actually pretty easy to explain. Hopefully I explain it there in a couple of seconds. This is an easy one to set an image in someone's head. Oh, it's a cinder block problem. Well, what do you mean by that? Take your carefully designed system, airplane, car, whatever, and now I'm going to come at it and smash it with a cinder block. And you say, well, I'm going to use safety engineering to solve that problem. I'm going to do hazard assessment, design mitigation, and implementation assurance. Now I've got a better door. Great. Now I'm just going to move 2 feet to the left and smash in the window. So you're going to solve that with safety engineering, and so on and so forth. Now your plane is too heavy to fly, right? Your boat's sinking, your car won't move, and your medical equipment can't even get in the door anymore. What does that set us up for? What do cinder blocks set us up for? It's an arms race, right? You cannot win. So what do you do when you're in an arms race? What do you do when you think you got to deal with a cinder block problem? The only way to win is not to play the game. You don't take cinder blocks into account when you're doing safety engineering. You live with your two operational assumptions. Operate as designed, okay? Maintained as specified. We do not pay attention to cinder block problems in safety engineering. That's why we call them cinder. That's why I call them cinder block problems. I want you to call them cinder block problems too, and help people understand that. We do not take those into account in safety engineering. We can't. Why? Because it sets up an arms race, and you cannot win. You end up with an over-designed system. You can't do it. So what does that mean? Do we just say, not my problem? No. Now, what is the domain of engineering that concerns itself with cinder block problems? Anybody? No. Legal? No. Maybe. No. Security engineering. Okay? How many of you ever heard the phrase, use the right tool for the right job? Right? Use the right tool for the job. Okay? Do not solve problems. Do not solve cinder block problems with security engineering. Do not solve security problems with safety engineering. They are different domains. At its root, safety engineering concerns itself with what shall happen. You are writing testable statements philosophically. You can prove those. You can create a test. It shall do this, shall do that. I've woken up screaming from sleep. Screaming shall, right? I've seen hundreds of thousands of shall statements in my time. Okay? Security engineering concerns itself with what shall not happen. You can't prove a negative. It's impossible. Therefore, the job of security engineering will never end as unprovable. They're just going to have to keep an eye on their adversary, and the adversary always has the advantage. So what does that mean? Do we ignore security engineering? Of course not, right? There is an intersection where we do have to be concerned with it, particularly in software. What's that called? Cybersecurity, right? So we've got some best practices in there, but a lot of them involve lowering your attack surface. And why is that? Because it's a cinder block problem. If we choose to not lower our attack surface, then we're back into the arms race, and we're not going to win that. We're just going to have an over-designed system that never launches. So we have to get out of that mode. We have to say, that's a cinder block problem. You have to minimize it as much as possible. And then you have to use a different discipline. I am not a security engineer. There are no slides beyond this talking about security engineering. That is not what I do. I do safety engineering. So you bring in a security engineer who understands the practice of security engineering, hopefully at a philosophical level, and understands the base concepts to help you through that problem. And one last thing. Stop using the word secure computing. Okay? You're trying to prove a negative. That's false advertising. All right? It is not secure. You cannot prove it's secure. There's no evidence that it's secure. Secure from what anyways? Okay? Use the phrase trusted boot, trusted computing, confidential computing. Those you can show chains of cryptographic sequences, one thing after another, but it doesn't mean any of those things are secure. It requires a completely different discipline for that. So that's what I got. I hope I've influenced you to start using the phrase cinder block problem, particularly when you're talking about safety engineering. And I'll be happy to entertain any questions if you have any.
I have the microphone here.
Hey, well, thanks a lot.
Yeah, no problem.
It was, pretty interesting. I have a question. What is your, you are pretty much aware, I guess, about SOTIF, right? So
say it one more time, please.
The SOTIF standard? the assessment of unintended?
No. In aerospace, we have DO356A that we use for cybersecurity. That's our cinder block specification, if you will, for software.
Because, like, in the automotive domain,
it's what?
In the automotive domain.
Oh, yeah, okay.
Yeah. So, basically, we are considering not only, the assessment of hazards deriving, from the safety violation, but also from unintended functionalities.
Yes.
And I mean, to some extent, it seems to intersect here what you are trying to mention. So to give you an example, let's take Linux as an example, right? So Linux provides different, APIs, different functionalities that can achieve the same functionality. However, some of them, provide more, more safety because, they have, like checks maybe on the input buffer that you provide, right? For example. So therefore, from a safety point of view, like in theory, as long as you document, what is your assumption of use, you can use, like either, those that are safer or less safer. However, if you do like an assessment of the intended functionality, indeed you will pick up a subset that, lower down the risk of misuse, basically of the integrator violating an assumption of use.
Yes.
So, and I don't know, but I think that to some extent this is something that, that is covered, in the automotive domain, by the safety standard that actually we are going to discuss about, in the ISO 26262 third edition by integrating it. So
it's covered in functional hazard assessment in aerospace as well. I think some of what you're getting at is like, to what degree of qualification can we expect from the operator? What are the boundary conditions of worst case scenario, pilot didn't get enough sleep the night before, or the driver's in a really upset state, what is the reasonable boundary? And that, like I said, functional hazard assessment is its own job because you just can't do that part-time. I mean, all that assessment has to come with tons and tons of data and analysis. So yeah, for separate, maybe there's 5 or 6 ways to do it. The integrator is responsible for figuring out the right way. Yeah.
Okay, thanks.
So in aerospace, what defines if it's a safety engineering thing that needs to be tested, or if it's a security engineering thing? Let me give an example. Let's say that Air France to Paris that fell in the ocean.
Yeah.
I believe the way they had was like the system is supposed to work with graceful degradation if you miss one pitot sensor.
Right.
If it's invalid data. If you have 2, you are done. It's gonna, the autopilot is gone. You have to have your own spatial orientation to keep it, right? And it was during the night. So what's the bound? Is the requirements that's gonna say what is covered on safety, what's covered in security?
Yes, absolutely. We learn from, it's always vexed me that humans learn best from disaster. I wish we didn't have that. I really wish we didn't have that. But we do learn from those disasters. And, that's when we find that our assumption, our functional hazard assessment assumption that 2 pitot tubes were enough, that was now turns out to be wrong. So now future functional hazard assessments say, oh no, that is definitely a safety engineering problem. There's not someone swinging a cinder block at the airplane to cause that to occur. Weather's a natural process. So therefore, we did not properly account for all the hazards. So that is definitely a safety engineering problem. Absolutely. Yeah, it just means we didn't know enough at the time. 100 years from now, we're still going to be learning stuff. We just hope it's a very tight sieve. We hope we've learned the big lessons. I don't know that. Ask me in 100 years. Okay, we got 2 over, yeah, good.
I guess this kind of parlays off that a little. And I don't mean to open a can of worms.
Oh, no, please, go ahead, open a can of worms.
But I was wondering if you could address like the MCAS problem from like 5 years ago. Like, was that an implementation assurance problem? And like, what kind of did you do to fix this?
To me, that's probably, I'm not speaking for Boeing, of course, right? I'm only speaking from public sources at this point. So I have the same information you do on this. So my non-Boeing instinctual, what I think, looking at that, is that's actually probably a hazard assessment. We didn't properly assess the hazards of going down that route. That would be my answer. That would be like my non-Boeing answer in that case. That just feels like a hazard assessment problem. You probably could argue, like, over our favorite drink, you could probably argue all night, well, maybe that's implementation assurance or design mitigation. I mean, it could go all over the map in that case. And sometimes those debates are fun to have. But to me, with my non-Boeing hat on, it feels like a hazard assessment problem. We just didn't take the hazard seriously in that case.
Okay. And then, like, how do you fix that problem? Like,
We don't do it again.
Thanks.
We learned that lesson, yeah.
So a couple of the examples that you brought up the Challenger example.
Mhm.
You're showing Feynman with the O-ring.
Yes.
In that particular case, a substantial portion of the engineers knew the limitations of the shuttle. They spoke
Yes.
up, and management said go forward anyway because it was a highly publicized launch.
Yes.
The case of Chernobyl, they were conducting a test. They skipped some critical steps in the test because they were pressured by management to do it faster.
Yep. Sounds like a theme here.
Yeah. And I think there was one other example.
Well, the Tacoma Narrows Bridge, that's
Yeah.
why I also brought that up. It was leadership had decided against a better design. So you're picking up on a subtle theme that I laid down.
Yeah.
Yeah.
There's and the answer that when you called out for what do you do when you're dealing with a cinder block problem, what I called out was limitations. How and in the case of MCAS, it's not necessarily that MCAS was, again, speaking from public sources.
Yeah, just public sources.
It's not even necessarily that MCAS itself was a problem. It's the fact that it was even there wasn't communicated to pilots. The limitations of it weren't quite communicated as well as they could have. And some of that comes down to perhaps pressure from management, but again, don't need to go into
No,
that
you're right, and I don't want to cut you off. I want to let you finish.
But yeah, I guess I think a huge part of safety engineering is the communication.
Yes.
And how do you tie that into your design?
Yep. Also, another theme that I hope is being picked up is that as an engineer, you actually have a moral responsibility to speak up. The guy at Morton Thiokol who was told, take off your engineer hat, put your management hat on, and what do you think, who approved it? He was miserable for the rest of his life over that decision. And I don't want any human being to feel that way. But I guess in some weird way, it's like, I'm glad he took it seriously. I just wish he'd taken it more seriously when he had the chance, right, to do the right thing. And so how would you act in that situation? Dude, I don't know, man. Like, everybody, they got to pay their bills and that kind of stuff, but there are good reasons to think very carefully how you proceed in those situations, particularly when you know something could go wrong like those. Hindsight's 20/20. That's the other part. Are you 100% sure you want to put your life and livelihood on the line? These are just quandaries, right? They keep me up at night. Fortunately, I haven't had to address any of them where I'm at. I have layers and layers and layers of stuff between me and what flies out of the factory. Yeah, that's what I'll say on that. Yeah. Any more questions? You guys have been a good audience. Thank you very much for your time. I appreciate it. Show you some more of the fishbowl as you leave for lunch.
I think we should start. It's time. Okay.
Okay, so let's get started. Okay, so today this session will talk about the Basil, the functional safety SPICE, that is a software quality management tool that we developed in the context of the Elisa project, and and especially was Luigi here is the main contributor and maintainer. Who are we? Well, myself, I am Gabriele Paoloni. I'm a senior principal software engineer at Red Hat, and I am involved in. I work on functional safety mainly, and I am involved in the in-vehicle operating system project from Red Hat. I also serve as a governing board chairman in the Elisa project. Okay, and Luigi?
My name is Luigi Pellecchi. I'm a principal software quality engineer at Red Hat, and I'm working on Red Hat in-vehicle OS, and I'm the full stack developer of this tool. So Gabriele is going to provide an introduction from a functional safety perspective, and then we will go in the details of the tool, its capabilities, some use cases, and stuff like that. So Gab, please.
Right. Okay. So as Luigi said, the first part will talk about challenges in managing quality in open source software. Then we'll focus on Basil itself. We'll go over its capabilities, some examples. We'll show, we'll present the tool architecture, the current roadmap, and then also finally we'll explain how to contribute. Okay, so I guess most of you are familiar with the V model, right? So the V model is what is demanded by most of quality management standard, and the main characteristic of the V model is that it is a development process that is requirement driven. Whereas, how is Linux or how is open source software development driven? Is it requirement based or probably not, right? So, well, as you know, open source is code driven, right? We have maintainers, we have contributors. So there is a proposal, it gets reviewed, hopefully tested sometimes. And and then it gets merged upstream. So now, effectively, trying to have open source software, compliant with the V model is a challenge, right? Because indeed, we need to reverse engineer the code and to create all the collaterals that are required. And indeed, a starting point is, having the right tools, right? Okay, good. So, and now let's talk about tools. So basically today, indeed, if we look at the quality management tools, these are, developed to fit within the V model, right? And whereas, the tools that are available for upstream projects are tools that are mainly used for continuous integration and continuous development. Because, for example, if we look at Linux, the Linux distributor, they deploy and Linux and they continuously integrate fixes, right? So, and so here, we need to somehow try to bridge this gap between, the tools that are, between the requirements that, come from the V model and, the natural code-driven development of open source software, right? Okay, so what is Basil? It is, as I said, it is an open source software quality management tool, and it makes it easy to manage requirements, test specification, test cases, and also it helps to maintain the traceability between all these collaterals. But why? I mean, how? I mean, this is, you know, indeed, every standard QMS tool is also able to do that in principle, right? But why Basil, right? So the first thing is that Basil supports Git, okay? And Git is the configuration management tool that is used in most of open source software projects. And basically, Basil, what can do is it can sense QMS evidences that are traced between each other. It can sense them changing, and as this happens, it will raise a flag to, you know, to trigger an impact analysis effectively. And also, it is designed to fit a CI/CD development process by focusing on code and specification first. So basically, the starting point of Basil is really the code itself and the code specification. And then requirements and tests are work items that are linked around code and specification, okay? And finally, you know, Basil facilitates open collaboration. Why? On one side, because it can export the collaterals through the SPDX standard, and also it implements friendly, or I mean, we try to make it friendly, HTTP API. Okay, and so in summary, you know, it can help to maintain QMS evidences in a context of CI/CD development flow. And now, I will leave the stage to the main developer and maintainer, so to the guy who actually did the work, most of the work.
Thank you.
And so, please, go ahead, Luigi.
Thank you, Gab. Hi, everyone. So, happy to be here today, and thanks for being here. Please feel free to interrupt me anytime, because I'd like to have some conversation here, so it's not a lesson I taught. So let me introduce. This is a software quality management tool, so it is aimed to handle and work with some quality-related work items, like software requirement, test specification, test cases, and test results. So there are a bunch of tools around, also in the open, as we heard before at the XN presentation. But why Basil is different is because it was built and developed in collaboration with the functional safety expert. And so creating those work items, you can create those work items only in relation to a reference document that can be software specification, source code, any kind of document that you want to focus on in your analysis, in your test coverage, in your evaluation. So Basil will differ between direct mapping and indirect mapping. From this picture, you can see that you can have multiple levels of software requirements, and you can nest under requirements test specification, test cases, and under test cases you can have test results, because Basil is also a test execution environment, and later we will see the details. Basil will propose multiple views based on the direct mapping, because there are companies that don't want to deal with requirements at all, just want to focus on test cases, for example. And here there is an example of how this tool looks like. So you on the left side will see the source specification, or in this particular case, a piece of Python code. And on each piece of this document, you can specify a set of work items. We have a particular work item in Basil that is named justification, that we use to provide completeness of analysis. So we can assign to each piece of the document a meaning, like an assumption of use to talk in functional safety way. And creating a work item is a meaning of specifying two pieces of information. One is for the work item itself. Here we will see an example of requirement. And this is just one piece. And the other piece of information is related to the reference document. So you have to specify the section. Tool will help you with some interface. The offset that is automatically calculated, and specification coverage. So you can specify a number that will allow you to understand if there is any gap. So this way, this tool will highlight the gap and will simplify a bit the contribution, but we will see later the details. So as a quality engineer, we usually need to keep track of any evolution because software is in continuous evolution. So we need to be able to understand at a certain point in time that work item, how it looks like. So and Basil keep track of any changes automatically. And you will see version number is a composition of two elements because the first number is related to the work item itself and the second one is related to the mapping. So as Basil supports user management, on any changes you will see the user that did the change, the date, the list of fields affected, and that are proposed in a view that is like that one. It's a modal view that pop up when you request the history of the element. So Basil also supports the reuse. That is a feature applied in all those also in vendor tools. And so you can have a software requirement that is used across thousands of software components. And at a certain point, you want, for example, to have just one component that diverge from the other. So you can do that in Basil with forking this work item that will keep track in its history about the work item that generated. So as software and specification as well are in continuous evolution, also you specify the mapping against this piece of the document. At a certain point, this can change and the link can be broken. So Basil will highlight this situation and will differ from two cases. So we can have two situations. One is the mapping no longer exists at all because this piece of code or this piece in the specification doesn't exist because it's changed completely. Or it exists but is in another position of the document. So Basil will allow you to beforehand analyze any impact of a possible evolution of this document, and will help you to understand the impact on the work items, and you can automatically fix the one that you name warnings when just the piece of the specification is shifted in the document. So it automates few processes to try to reduce the manual effort. But specifying software components, in Basil you have to specify not the reference document. In general can be, as Gabriele said, linked to a Git repository that is remotely. And on doing so, you can point to the head of the repository. Imagine a man page. You can point to the head that you will follow the evolution, so you will face some breakage in the mapping. No? Or you can point to a particular commit hash if you know that for version 3 of this software component, I want to focus on that. Commit hash has some limitation in case of the rebase of the Git repository, but so putting some policies on those repository, we can be quite sure that that will be an item fixed in the time. So in the last few months, I introduced user management because with Elisa, we are going to create a public instance of this tool because we want to do upstream some analysis, create some requirements for Elisa. And so I introduced the user management with the user roles and user permissions at software component level. So there are 3 different roles: admin, user, and guest. And there are also the possibility to join this a public instance without an account. In that case, you cannot modify the database at all. You just will be able to read the public content. And if you will be registered, if you join an instance, you will be registered as a guest. That means that you will be able to leave comments on work items. But to be able to apply changes, to write to a software component, to create mapping and work items, run tests, stuff like that, you need to be enabled by the software component owner. So he needs to trust you. And so trust is something that we heard a lot during this summit. So it's something that Basil is taking in mind during the development. And the admin is able to disable account, reset user password, and so change user profile, and so it is able to administrate your account. So Basil can be deployed with Docker container. So container files are available in the Git repository. I'm proposing this slide because when you create an instance of Basil, at the very beginning, he will initialize the database and create the first admin user. So at that time, you will be able, specifying a build argument admin password, you can specify the password of the admin. So that will allow you to specify your password. So user permissions on software component level are read, write, edit, and owner. So that allow you to restrict the access to some software component in case you have a customer that require NDA, for example. So in that particular case, you can allow only people that signed the NDA to access such software component. So it's born as a collaborative tool. So we want to leverage any contribution in general. And that's why it's born as a web application. And also it gives us the possibility to leave comment on work items. And user can approve, reject work items, and the particular thing of this tool is that he simplifies a lot and highlight where a gap exists. So you're creating work item, you create some information, and specifying the specification coverage, you are highlighting a gap that is on the right is reported as a red label, and the overall coverage is reported on the left side with the leaves icons. So it also supports notification. You can specify for which software component that you want to be notified. So if a new user joins, if a test run has been requested or completed, if a work item change, or anything. So in the last few months, I introduced the test environment in Basil because a test result is absolutely a work item that we need to take in account, creating the traceability matrix for any safety critical project. So the challenge at that time was to be able to let this tool able to interact with any kind of test suite written in any language. And the second challenge was to run this test on any kind of test environment, any kind of suite. We name it suite in quality management. So the solution is a tool, a Python library named TMT, developed at Red Hat. Here you can see some number of these tools. We have more than 2,000 commits and more than 60 active contributors that works on this tool. This tool provides from one side the abstraction layer we need to describe any kind of test suite. but it also is able to describe other things like test plan and user stories. And from the how you can do that, you just need to create a metadata file in FMF format that stands for flexible metadata format. And here you will see an example, so you can specify the test entry point depending on the particular your particular test environment, and other information, and the full list of statements that you can specify is reported in the TMT documentation project. Here is how the test run view looks like, but let me just explain how I solved the second problem, the provisioning one, because the TMT provides also a provisioning system. So it provides a lot of solution, different provisioning system. We just are leveraging two that are container. The default, if you deploy with the container file that are in GitHub, is a Fedora container. And the second one is connect, that will trigger the execution to any remote machine via SSH. So here you can see an example. The first one is via SSH. There is the IP address of the suite, the test result. It is possible to link bug in Basil. And the second one is on the default Fedora container provided by Basil. So Basil will provide to you also a system under test. So TMT, during the execution, will generate a folder structure and some artifacts. The one, for example, that is important is this log.txt that give you information about the test execution, and there is a complete trace of the test execution. But TMT also, during the execution, provide the access to some folder, and it do that via environment variable, like that one in the slide, TMT plan data. So if you, in your test, you can leverage this variable, and you can copy your artifacts to that destination. If you do that, you can access artifacts from Basil interface. So you can create a requirement, test specification, test cases, run your test cases, see the result, access the artifact. You have the full traceability matrix in place, and you can create an account for your certification body to access your instance and say, please look at my traceability because I'm ready for submit my my artifacts. So Basil is a software quality management tool, but in automotive, as per my experience, but also in any embedded company, no, the toolchain is not so easy. It's not enough to have one tool. So the idea that is behind this think of supporting SPDX is to be able to integrate this tool into a complex toolchain. At the moment, Basil just supports the export of artifacts of work items in SPDX, but the plan is to fully integrate it going forward. The other thing is that this tool provides an HTTP API. So any action that you perform on the user interface, in reality, is done by interacting with an HTTP API. So you can leverage this HTTP API to automate any action that you can do manually in Basil. And then we will see an example, the example. So the first example that I want to show to you is the possibility to, this is an example of an analysis of a kernel syscall. In particular, this is a nanosleep. And you can see on the right that I created the two requirements, and I linked a test case from LTP, the Linux test project, under a requirement, and I was also able to run it. In Basil GitHub, you will see an example of to run a LTP test and to run also glibc, a single test from glibc upstream test suite. So the idea that I'd like to propose to LTP is to have an instance of this tool and trying to create a relation between existing tests and man pages. So the discussion started this week, and let's see how it proceeds. This is instead an example of integration of Basil inside a continuous integration workflow. So on the left, you will see this icon just to simplify that we are merging some code in our repository. What Basil can do interacting with the API is, for example, list software components affected by the changes, because we are linked to some files, so we can understand which software component has been affected by the merge request. We can list requirements from the components, test cases, and once we have the list of test cases, we can trigger the execution, wait for the results, and then we can also automatically file bug and link back the bug to Basil. And then we can do, if we are calculating the specification coverage with some mathematical function, we can update the specification coverage, and then we can do other things outside this workflow, like generate a report and enable another stage of this of the pipeline. The last example that I want to show to you is something I demoed months ago to the Zephyr project, because they have a different and unique use case where they have requirements in file. So they want to have requirements in file in their Git repository. So I learned by myself that we still can use Basil in this case, because we can create a dummy software component and that is linked to the requirement file in the Git repository. That will give us the opportunity to create the requirement in Basil that are linked to this file. So anytime this file will change, we will be notified, because we will see a break of this mapping in Basil. And so as Basil is able to reuse a work item, we can reuse those requirements across other software components that we need, we really want to use for creating our traceability, to run our tests, to understand test coverage and stuff like that. So anyway, if you have requirements file, it already exists an opportunity to still use this tool for your quality management. 2 words around the tool architecture. So it's a web application. It consists of 2 pieces. One is the front-end application, and the other one is the REST API. And a user can interact with both. To the front-end, just via browser. At the moment, the only supported is fully supported is Chrome, because it is able to really leverage the user interface to simplify the selection of the piece of the specification on top of the one you want to create work items. And the database is abstracted using a Python library that is SQL Alchemy. The default persistence is an SQLite tree database, but you can change if your project is so big, you can change and use a database server. It's just a matter of changing a few rows in a Python code. So the API is written using Flask API and interact with, so the front end interact with the API via HTTP using exchanging data in JSON format. The front end instead is written in React and is leveraging a framework named Patternfly. Patternfly is a user interface framework developed at Red Hat. It has a great attention to accessibility. It's an open source project. And it provides a lot of components, layouts, pattern, and also it's fully integrated with Figma, that is a tool used by user interface expert to design the user interface. And we did this way. We created the user interface with the Figma, and it's not my work, it's work from user experience team thread. And this tool also provides a seed project to give you the opportunity to create a Scratch application really quickly. And Basil was created using this said application. Slides, anyway, are available on GitHub, that under the Elisa tag. Anyway, feel free to. 2 words around the roadmap. The most important things absolutely is to create a public instance of the tool with Elisa that will show tool capabilities to anyone that want to reach this tool. And we have other ideas in mind, someone really related to functional safety like baselines, because sometimes you want to, once arrive the moment that you want to certify, you need to have the picture of all the work items, so that will give you the opportunity to create really a picture of all the work items at a certain point in time. And there are other few things. So there are, those things are reported as issues in GitHub. And here are 2 words on how to contribute. First of all, I can suggest to access the documentation that is available at the link here. Basil, the Fusa Spice, is hosted by Read the Docs. And that will give you the opportunity to understand how to spin up your local instance of this tool and have some try locally. And you can propose any changes, features, whatever you want. I'll be happy to onboard any request. Yeah, I already said there are a bunch of issues opened, so it's also a good starting point if you want to contribute to the tool, having a look to the issues. Last thing is that, a few days ago I posted on LinkedIn a live demo of this tool that I'm trying to send it to the LTP Linux test project. So we'll give you a live demo of this tool. So if you want to see it, please go to LinkedIn. And anyway, with Elisa, we are going to create a web page dedicated for this tool where we will list also all the videos, all the tutorials, any documentation. So stay tuned for that, is coming. That's all from my side. If you have any question, I'll be happy to. Thank you. Please.
I have the microphone here if you have questions.
Okay.
I saw you have can support multiple documents for one software component. Just wondering, that means that is for one, so have one requirements, you actually can have multiple places, the multiple functions, for example, to support a single function.
Let me go back to one example. Yeah, if you see, for example, you are creating a software component is a matter of specifying your granularity. You can create, for example, let's take the example of a syscall, that can be a software component, or you can do the same way at the library level or a subsystem level. You can create your software component with the granularity that you want. And once you create a software component, you can specify the reference document. It can be a manual, a specification, also the source code. So if you have, in this example, you can see a piece of the man page. You will see just one piece because of the slide, but the page is long as all the man page. So this piece of the man page has been assigned to 2 requirements at the same level, but you can have multiple requirements without any limitation. You can create the nesting that you want. And under each level of requirements, you can create a mapping of test specification, test cases, and justification. Test specification are just a description of a test maneuver in Basil. So the idea is to leverage some expertise that will give you the opportunity to describe the maneuver that you have to perform, but is not connected to any implementation. the test case instead is the implementation of that specification.
I see. Okay, thank you.
Thank you to you.
Any other question?
We have a few minutes if you want to have any questions. No. How many of you are involved in or are working with the software requirements tool? I imagine. All vendor tool, I mean. Oh, probably. Okay, and so. Yeah, and in comparison with the tool that you are using today, that I mean, I imagine that have some. So I don't want to say limitation because no, but I worked with several vendor tools, and so what I want to say is that Basil is trying to simplify things, put things together. Things that have a great added value for the one that really need to do the job. So in the same place you can create the mapping, the traceability, run your tests and access artifacts and so. And I think it's a challenge sometimes on a vendor tool that really focus on requirements management. Okay.
So if people want to get involved, how do they? Like, do you meet on a regular basis? Or if they've got questions, they should put something in as an exchange. How do you want to start to build a community?
Yeah, at the moment we are discussing periodically at the Elisa tool investigation working group. And yeah, that is the current community. So that can be an opportunity because please get.
So basically, if you're interested, look online to the website, see where the Elisa tool meets is going, subscribe to the mail list, and then feel free to show up.
Yeah, in the mailing list, we mostly discuss features, or we talk about the deployment on the Elisa server. That is the ongoing discussion. So yeah, that can be an opportunity to be informed about the evolution of this tool. And so, as I said, using Docker container now is quite simple to spin up an instance, so you can have a try also on your laptop. So the great thing is to have a common machine where anyone in the company or in the community can access the tool, so we can leverage contribution. And another thing that I want to, because I have 2 minutes, another thing is that why I asked the Linux test project to try to onboard this tool, because the suggestion from their documentation at the moment is if you want to join and contribute, have a look to the man page, try to understand what is, for a syscall, what is the gap, and create a new test. That's great. The only problem I see is that anyone is doing the same analysis, and this analysis is anytime is lost. So if Gabriele tomorrow want to write a test for nanosleep, I have to do the same analysis another time. So using a tool like that, you will leverage any one contribution. So if I do the analysis, I can put the analysis in creating the relation, and anyone will know that the relation exists and can focus only on the gap. That's not only from Linux Test Project. That is anyway a great project that we are leveraging a lot in Red Hat, but for any test suite. Okay, so thank you all.
Thank you.
Okay, just to share this.
So you might be using your NVIDIA graphics card, would appear. That's full screen. Like, you know, since you changed the resolution.
It's better it's not stretched.
Yeah.
Okay.
This is switchable right there for question and answer.
Okay.
If you don't end up passing it around, just repeat the question because it's being recorded.
Sure. Is there a laser pointer?
A laser
A laser pointer? Okay.
Trying to take as much of the safety out of the Linux, but still having some solution. Pressure in the cylinders, the length of the movement angle, and we're calculating and comparisons with the traceability we get from the volumes. It's more like a personal interest at the moment. Nevertheless, I'm trying to push it to the roadmap because we are going smaller fields, which the MPUs are right now they're metal. I would like to have an operating system on it. And yeah, maybe and less hassle with checking between MCUs and stuff. So more abstraction. Yeah. So separate versions. That's why separate version. We are looking at one thread, especially the guy in Germany is trying to get separate. It's a big still clarifying how we can make it visible now. So, because we are also planning on having smaller controller based on boards. One of the guys who oh, you were? Yeah. I was there in the very beginning. We discussed with the two
Perfect, thank you. All right, looks like we're over time already, so let's start. Thanks everybody for joining. My name is Dylan Dawson. I am part of the partner management team at Electrobit, and I'm also a Linux evangelist. For us, that means sort of storytelling and finding topics around that intersection between Linux and automotive. I'm also located here in Seattle, so my commute today was pretty short. Just a little bit of context here about Electrobit. So we're 4,000 strong. We've got in 24 offices over 11 countries. We're a wholly owned subsidiary by Continental, but though strategically we act and think independently. We have sort of saying that we have around 600 million vehicles on the road today with our software, and that's over 5 billion embedded devices. So our competency is around automotive grade embedded software and engineering services. So it's both of those things that allow us to give our customers a solution. So it's a really tough mission, but something that we're really proud of. So I'm going to talk today about a proposed marriage between existing automotive standards, this is ASPICE, and open source excellence. So what makes us positioned to talk about qualifying software, open source software inside of the automotive stack? Because we've done it. Rather, we've helped our customers do it, and what you're looking at here is the ID3. I think we don't sell these in the American market, but you guys might be familiar with the ID4. And this is seen as really, I think, some of the most sophisticated architecture driving around today. So with this, we have 3 VMs that have qualified via Linux instances in them. And then Electrobit has also offered the AutoZar adaptive and classic middleware as well. So we're pretty proud of that stack. And this is all for the Continental application server, the ICAS-1 project. So I'm going to talk a little bit, build some context here around our actual Linux offering. So we do partner with Canonical to build a mini distribution based on the Ubuntu. For this, when I say mini distribution, I think a lot of you guys get that we have to trim down a lot of the Linux features to fit inside of the constructs of the automotive hardware and software. So with this, we've cut out probably about 70% for our QM Linux, really keeping only the features that are important to us. And we've also continued to layer on sort of features and extensions that we think as options, I should point out. So for runtime management, certainly you can use systemd, but we have an alternative, smaller. We built other features or continue to integrate other open source options for event logging and management, containers, Yocto injections, update APIs, things like that. So really trying to build a tailored version for automotive. And so in this relationship, Canonical, gosh, this is supposed to be off, apologies. So yeah, Canonical's job hasn't changed. So this is their job, our partners here at Canonical continue to do the same thing, right? Which is to source feedback and contributions from the open source network, package it, maintain it, test it, keep it secure. But one thing they don't do is offer liability. And it's that liability that's really important to automotive, and that's what today's speech is going to be about. So I've got 4 sections, and hopefully by the end of this, you guys will have a little better understanding, a little clearer path to community source quality assessment for automotive. And for us, that means grounding it in ASPICE principles, but still maintaining and preserving open source excellence. So for the first section today, I waited 7 slides to show everybody the evolution of EE architecture. Sort of a joke here. I think we're seeing a lot of this slide, especially to set up SDV topics. So SDV, or a software-defined vehicle, this is the uncoupling of software and hardware. This is the increasing amount of software that's going into the car. And so where are we today? And I think that even over here in 2035, that's a little aspirational. I think maybe we might remove that and really just talk about going from flat architecture to zone computing. So where we are today is definitely right here. Moving out of spaghetti architecture, right, which is microcontrollers, actuators, this gauntlet of wires that have lead to one feature in one unit. Our OEM partners are very much trying to consolidate into domains, and that's really where we are right now. The really exciting about this thing for Linux is that this brings on the HPC, right? So this is making something like Linux possible. And so we think that very much that Linux is future-proof. I think that's debatable, but Linux can probably support all of these architectures. So we've talked a little bit about the motivation. Definitely we see that the OEMs are very excited about the opportunity to use Linux. It's free, right? The price is right. But we also might think about how sometimes free is the most expensive. So there are maintenance concerns here. But they're very interested in using Linux because of its established tooling and the faster development cycles. And so to kind of get into that a little bit, I think it's important to look at where OEMs are investing, and that's in the digital cockpit. To do that, they need to hire, and they are hiring quite a few application developers. And what Linux will offer them is a greater pool to do that recruiting. The reason that they're doing this is they're getting past that sell once model, right? Here's the keys. Here's our service department. They're building out ecosystems and looking to have subscription models and building out rich applications that will grow brand loyalty, that will improve differentiation for their platforms. And to do that, they need to hire a lot more developers, and having Linux in their stack allows them to do that. Another thing to kind of point out here is this idea of security through obscurity. OEMs are really excited about this idea that they can go to an open source community. It's all out in the open, quick responses to vulnerabilities, versus closed source. So a lot of real interest there, but we have to kind of fold in the issues in automotive that are existing, right? So this is around liability and warranty, and you'll hear me talk about this a lot today. There's high stakes here. We've got the U.S. has a billionaire in Texas who is sort of rewriting some of the safety cases, and we have also some stuff happening in APEC too, in Asia and China. But for the most part, the vast majority of OEMs are really focused on using ASPICE to cross that threshold, to make that choice to take over liability and warranty. Maintenance. One thing I was thinking about this morning is how many times I bought like a really beautiful Apple notebook, right? It's a nice piece of industrial engineering. It's lasted me 10 years. And I've done it 2 or 3 times now. At the end of life, it seems like it could keep going, but it's that hardware that craps out, right? It's the software that pushes the boundaries of the hardware. How do we begin to think about that for automotive as we begin to look at the software-defined vehicle? I know it's not the same thing, right? Because we have our cars are such a big part of our household income. Electrobit, paired with our fully open source QM Linux that you're looking at earlier, that is part of our value add. We have a 15-year maintenance and support package that we're aligning with that stack. But we have to begin to really think about how much software we're putting in the cars and how that affects the end of life. Expectations for quality and control, risk handling. We have, it's a really interesting time to be renegotiating how we assess quality in automotive. We have, we're increasing the features, we're increasing the amount of driving that our software is doing. And if I back up and think about liability and warranty, that's just for the system itself. If there's an event, we look at the driver, we look at the system, we decide who's at fault. The more and more that we take control, the software takes control, the more and more we have I think, a changing of the guards, of a shifting landscape. So is now the right time to really be renegotiating how we assess quality? It's debatable, right? So there is a standard, and I'm a couple slides away from showing it, that I really want to fold this whole thing into, which is ASPICE. And I don't want to move forward without talking about the elephant in the room here, which is that automotive sees the value of Linux. We understand its high quality. The problem is it just wasn't made here. Certainly for Electrobit and the example I'm going to show, it's not something that we were part of. So it's hard to fit into the ASPICE model. So here it is, a first look at ASPICE. So what do you see? Certainly the fee model. I think I heard it, okay. Also a bit of waterfall. And I can talk about how Electrobit in our process was able to integrate some Agile into this. But the important thing here is that all of the software implementation, millions of lines of code, right there, that's it. It is the process that's in focus. And that's what, I just kind of want to establish that early here. ASPICE is about process assessment. And we'll look at this again. Again, open source, millions of stakeholders. Mastery, right? This is really high quality software. That's not in debate. The problem is we need to find a way to fit this into our own quality assessment. So finally getting to the problem statement. I think you guys can mostly already get what that is. And I shouldn't call it a problem statement. I should call it a challenge statement. But automotive OEMs have a long-standing tradition of using ASPICE to make that liability claim, to take over warranty and liability. It's working, right? There is a lot of investment in doing this, and it's a lot of process. It's not cheap, free, or easy. The issue here is that it doesn't account for pre-existing software, like open source, like Linux. So what do we do? So this next section is an overview. We'll go into more details in my third section, but I just kind of want to lay out a couple things, starting with where do we deviate? Where did Electrobit deviate in our assessment? How do we justify those deviations? What are our compensation measures? And how can we be sure that those compensation measures are sufficient? So again, looking at the PRM, or process reference model from ASPICE. And I'm going to draw your attention to these 16 boxes. These are for the VDA scope. VDA is a German acronym. I can't pronounce it, but please feel free to look it up. But for our purposes today, we're really going to look at this as the boxes that are subject to assessment. And where we deviate, right? What are the deviations? Most importantly here for SW3, software design and implementation. In addition to the unit verification section, we're simply not doing it. It's not done. To some degree, in SW2 and the architectural design, as it pertains to the interface definitions, there are some compromises as well pertaining to the outcome of 3.1. And then in SWE5, thinking about the unit integration and verification, there are some concessions there as well. So how do we justify these deviations? Two arguments here. The first is that this, in fact, is not a software implementation project. This is a software integration project. It's different. As such, any detailed design documents that we have are not meaningful, unit tests not useful, simply it doesn't provide added value. The second argument here is that the interfaces are public for Linux. Thinking about package dependencies, the software installs correctly, right? And I think we have confidence in the alignment around the dependencies. The man page is another really good living document, something that we can refer to, and it's very much public. So going back and documenting things simply isn't meaningful. So what did we do? What was our approach here? As a consequence, we're wanting to adapt the goals for specification and architecture. Our goal now becomes not to design or implement the software. This becomes selection of software. And that pragmatic software selection is, I'll go into more details in further slides, but that becomes the rigor here. We also want to enable a layered verification. And into those two strategies that I'll go deeper on. So here's a better look at that, sort of at our solution and the compensation measures that we've applied. As discussed, we're not looking at this as a software implementation project, but that of an integration project. For this, we were looking at architectural design records, ADRs. We've sourced this from other automotive standards, ISO 15288, I think to be specific. But this allows us to map out and enable informed decision-making around software selection. The second thing is that layered verification strategy. This utilizes existing measures, right? Work already done, but layers down work with our partners and ourselves to show successful verification. So how can we be confident that these countermeasures are sufficient? For this, we use, there's an announcement coming later on this month. We're talking today about quality managed Linux, but Electrobit will make an announcement about Linux for safety applications very, very soon. And in that process, we've used this standard IEC 61508, and we've located this rigor here as a reference. And it states, without objective criteria or limited objective criteria, we can use black box testing, we can use judgment. This is all sufficient for software integrity level 1, which is in alignment with quality managed. This allows us to do black box testing, go to SMEs, get their opinion, document the dialogue that happens around software selection. So this gives us confidence in what we've come up with. So more details on the solution, right? I've got 2 more slides here that kind of dives deeper into both of these compromises, or strategies, I should say. So when we look at that ISO 15288, we have found a defined decision model workflow. And this is what we're using. It's subject matter expert driven, guided, systematic, and partial. It allows us to, and you can see a sort of a diagram there to the right. It allows us to kind of supplement our decision making and the flexibility to sort of ramp up or ramp down based on the use case or the package that we're looking at. But in the end, it gives us that oversight. It gives us that the documentation that the right decisions have been made. But we're also looking for other spots, to supplement this, especially in the free and open source community. So looking at licenses, do the licenses apply to automotive? Is this an active community working on this package or this code? What is the downstream maintenance repercussions of this? For us, that's sort of easy because I think the first question we ask is this maintained and supported in the canonical distribution? But we also look at the product quality influence factors from this other ISO, 25010. Looking at the functional suitability. What does this package do and doesn't do? Is this package too big? Is it performant? Will this fit in the automotive context? Is it secure? How many vulnerabilities are introduced over a time period? So all those things allow us to sort of make our safety case. When we talk about the layered strategy, we first want to acknowledge that Linux is highly tested and is of high quality. We also know that our partner Canonical does further tests and is while it maintains Ubuntu. We also ask Canonical to do further testing specific to Electrobit's use cases and maybe to our hardware. Once we get it ourselves, we do some testing on our own. This is around the reference configurations. And we even use other open source test suites like LTP and others. We also do fuzz testing. right, for security purposes. So this layered testing approach allows us to, you know, sort of have some confidence around that quality decision. So just to wrap things up, you know, I think all of automotive is aligned around a vision of the future of mobility, which is safer, cleaner, easier. And for that, we do need the help of the free and open source community. That adoption is already happening, right, especially with Linux. But it's qualifying and maintaining these free and open source libraries, which is brand new. This is not a new argument. ASPICE is not the only monolith automotive standard that's being revisited. You know, I think about functional safety. The boundaries or the limitations when we think about automated driving and things like that, these are becoming discussions, right? There's workarounds that are in progress. So ASPICE is not the only one that needs to grow here. But if we're going to do that, we absolutely need to preserve the free and open source community, the principles, the benefits of why we're doing this. And that's something that we don't want to forget. Excuse me. So 2 more slides. This one here is sort of an open question. So I want to, this is a framework that we've gotten from a German group, ZVEI. And it does a pretty good way of you know, sort of compartmentalizing the readiness of an organization and their readiness to support the free and open source libraries. I think the Lecter bid is probably somewhere right here. But we have ambitions to make it to level 5. And we're very focused on being a good citizen of the open source community. And so the proof of that, better to show, not tell. So just an open invite for everybody here to kind of come check out our open source contributions. This is some, not all, but a pretty good place to start. And I think that's it. I would love to talk to you if you have questions or want to talk about your HPC project. So thank you.
Okay, I've got the rate of change in the Linux kernel these days at tip is 9 changes an hour. The rate of backports is about 1 change an hour. How are you working with that in your model?
Our strategy is, you know, is not to document all of those changes.
Okay.
Right. Our strategy here is to accept that we are integrating pre-existing software and that we cannot document those. Now, our product strategy is not to change the kernel, you know, every time that there's you know, perpetually, right? We, you know, we work with our customers to maybe freeze. We do have our product now I'm talking about.
Yeah.
We would freeze a Linux kernel, and we would have an option to maybe update it once or twice through the vehicle's lifetime.
Okay, and so so basically you're looking at monitoring or working with Ubuntu to monitor the vulnerabilities that may be relevant and then assess putting them in or not? Vulnerability fixes specifically, not adding vulnerabilities, but adding the fixes to them.
Yes, absolutely. So that is the
those are the 2 or 3 times a year ones?
No. You remind me of you know, sort of talking with a group that was, you know, automotive embedded software is just different, right?
Okay.
All these cars are getting connected, right? We're starting to come around to general IT ideations, right? Which is pushing value all the time, pushing fixes all the time. We have cybersecurity regulations coming in Europe in July this year. Stakes are getting higher. No, Electrobit provides not just an open source QM Linux stack, but the maintenance story for 15 years. And that is the response to CVEs, rapid responses.
Years?
Right.
Okay.
That is not part of fixing the Linux kernel.
Okay, cool.
Yeah.
Any other questions? Oops. Okay, you can do it.
Hey, I have a question. So I mean, with respect to the tailoring that you took, you know, for ASPICE, I think, I mean, I'm not surprised, and actually I think it's, you know, a wise choice, you know, to decide not to do like the software unit, you know, design and software unit testing. However, I'm a bit surprised about you being inspired by IC 61508.
Mm-hmm.
The reason being that if you look at the work that's been done in ISO PAS 8926, it was actually going into that direction.
Mm-hmm.
Because what we did is basically to, you know, we recognized that, you know, the ISO 26262 was not fit to qualify complex pre-existing software components. And the starting point was to define criteria,
mm-hmm.
you know, to classify, you know, these software components. Because at the end of the day, what is the problem, right? So what is your software unit? You said, you know, we're applying a black box approach.
Mm-hmm.
Yes, but what is your box? What are the criteria for the definition of your box? Because
Sure.
if the box is the entire operating system,
right.
Is that acceptable? Maybe not, right?
Sure.
Basically, what are the boxes? You know, are the boxes like the glibc a single box and the standard C++ library another box and the kernel another box?
Right.
Is that acceptable? I don't know. Maybe, but for sure, maybe probably more acceptable than, you know, having the, and, you know, and this is the intent behind ISO PAS 8926. So they define the classification of these boxes, considering complexity criteria as well as provenance criteria. Okay.
Okay.
So so basically, my ask is, how did, you know, what are the criteria that you used for the definition of your black box?
So it depends on use case, right? That's, you know, and I'm not an expert here. I can certainly, you know, point to people who are more intimate with how we crack that. But I just, maybe for reference. You know, we're looking at this. You know, this is IEC. This is the standard you were referencing. So this is a safety standard, right? This is what we've used for our Linux for safety. But in that, we have uncovered what we think justifies a rigor that is comparable to QM Linux, and that's you know, software integrity level 1. Being able to have SMEs and have a dialogue. This is how we're sort of reinforcing that decision. I don't have more details on specific, you know, black box testing was how much is enough, but I'm happy to get you in touch with somebody who is, if that's of interest.
Yeah. I mean, I would be curious, but
yeah, happy to do it.
Yeah, thanks.
Yep.
Hi, I found this very interesting. Thank you.
Awesome.
I guess I have maybe like a high-level question. As somebody who's in the automotive industry, as an insider, I'd just like to hear your thoughts, right, personally on this. But when I look at the automotive industry today, and I'm currently an outsider trying to figure out a way to break in. So full disclosure, I'm not any of the companies that I'm about to mention. But I see the legacy auto manufacturers really struggling to adapt to software-defined vehicles, you know, zone architecture, agile, all the things that, you know, you would see in software engineering. But there are a few, you know, notable exceptions that are not legacy automotive. Obviously, you mentioned, you know, Tesla. But in Asia, right, we've got Kia, you know, making very good inroads. And of course, there's a number of Chinese companies doing some very interesting things. But when I look at, you know, I think CARIAD, you know, Volkswagen's software issues have been, you know, well publicized. Ford, GM, Toyota especially as well. Like, there's a lot of legacy auto manufacturers who are really struggling with this. So I'm curious about your thoughts on, like, are the folks who are doing better with this, the if I call them an innovators or whatever term you want to use, the folks who are doing better with this, are they using these same processes that you're describing? Are they using different processes? How are they, apparently, maybe this is an incorrect assumption, but how are they further along on that 2035 slide, right, than the legacy auto manufacturers maybe from your perspective?
Well, yeah, so I have an answer here, and it's, I don't think we want to be disparaging towards, the legacy OEMs. But an example I often think about is that Model T waterfall, fabrication line, right? Henry Ford built it, right? It's that step, 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 step. And this was embedded software. If there was ever software, it was embedded. And I kind of talked about it earlier. It's you push it every 6 months, right? This is a legacy. This is baggage. As these cars are getting connected, pushing value, building out ecosystems, this is new territory for automotive. Something that they're getting quite good at, either by paying for it, acquiring new skills, or just completely redefining how they build software. It's hard to become a tech company, and the tech companies sense that, right? So you've seen Google and Amazon. There's others in Asia that really sense we do software really good. Automotive needs software. Let's talk. So I think your question is who's really leading here? It is that legacy OEM that's having a difficult time in a transition period where they're no longer, they're deciding where to invest. Is this around ADAS or this mission to get to level 4, right, that we were talking about maybe 5-10 years ago? Do we now change our platform to have just electrical, a brand, start from scratch and build electric vehicles? Is this where we put our budget? What do our customers want? On top of that, this overwhelming complexity around being able to build software is just brand new. It's just not in their DNA. And Electrobit's been on the ride for a lot of really fantastic companies, helping them make this acquisition, through maybe buying, acquiring different companies that help them do this just organically, learning it themselves, pair programming. It just hasn't been an easy road, right? I think there's just in opposition of this idea of knowledge work and building software is this Henry Ford fabrication line, right? Concept, waterfall. They're a little bit in opposition, but time is their friend, right? They're continue to put out products, and they're growing their digital cabins, which I think is a really good, that's a really smart choice, right? Because that's going to bring them differentiation and help them find new business models. It's a lot going on. Yeah.
I just had one other question I could ask very quickly. You said that their digital cabins, they're coming around to embracing Linux. I'm curious, what were some of the players using before Linux?
So, if we're really talking about infotainment, Android Automotive is really, Linux isn't a perfect application there. I think it's a great companion application, especially as, if there, when there becomes a safety option. But no, the elephant in the room is absolutely Android Automotive, when it comes to infotainment stacks. Linux and Linux for safety has, I think, really good applications in ADAS. We're thinking, that is probably the easiest place to really build some momentum for Linux. But I guess time will tell. Yeah.
Thank you. Following of the last question, so yeah, actually we are a vendor to help legacy OEMs to obtain certain technology power. Yeah. So I'm seeing the EB companies doing a lot of efforts at open source world. It is quite exciting and thrilling to me. Another company I found out is Apex. Yeah. It's great. Yeah, I'm so happy. So the things are changing. So what we start from as an open source company, and to deliver while we were delivering our solution into the vehicles, yeah, we found out the same situation as you said today, and the AP part is fine, but while we are doing the CP part, it's inevitable for us to work with the tool chain. Yeah, one of our customers is using EB tool chain, another one is using ETAS.
Okay.
So my question is like more or less like a proposal here. So since you guys treated the open source software as a black box, is that possible for us to work together to add a plugin at your tool chain, so can compile our open source software into your firmware while doing the code scanning and the assessment during that process? So in that case, yeah, I believe the things gonna get a lot easier, and we're gonna build integrated products, and you guys have a better ways to observe the information and goodness from open source world. Yeah.
For the Linux tooling, is that, or are you talking about the outer
not only Linux tuning, but a lot of application and open source project lives on it. You know.
Okay.
So yes, like SDKs, like other messaging framework, like infrastructure tools. Yeah.
Well, let's talk. Maybe exchange cards afterwards. We have a self-certification project underway. We can maybe talk about that, where Electrobit is allowing or giving the tools for our partners to sort of self-certify around Linux, sort of get that stamp. As far as probably the studio tools or the IDEs for our classic and adaptive AutoSAR stacks, those are a little bit more proprietary, but yeah, happy to talk about where we might partner, 100%. Yep.
I guess no more questions. Well,
super. Okay.
Yeah.
Well, thanks
Thank
everybody.
you.
Really appreciate it. Yes. Go ahead, please.
So, did Canonical build something PLV free for you guys?
No.
No.
No. I
That's going to be a challenge for